while you watch the broadcast and the launch. This here is a bingo card that you can print out by just scanning this QR code you see on the bottom right-hand corner.
Cities is still closing out, that's why you still hear the audio.
We also have the website there if that's easier. That's scijinx.gov/goes-t-launch. Noah has a list of words that we've incorporated into this show, so be sure to listen for those words and see which family member or friend wins.
Cities to pop
But
out.
first, let's meet the talented team of people helping to cover today's launch. We have meteorologist Arlena Moses monitoring the launch
Cities
weather.
takes forever
NASA's
to
Leah
freaking
Martin will
close,
introduce
dude.
us to key players in the GOES-T mission. And we also have our NASA launch commentators, Daryl Nail and Mick Woltman, inside with the launch team there. You know, Mick is an engineer with NASA's Launch Services Program, which is managing today's launch. So guys, the 2-hour launch window opens at 4:38 p.m. Eastern Time. How are we looking?
We're looking great so far, Megan, and thank you. Welcome into the Atlas Space Flight Operations Center here at the Cape Canaveral Space Force Station. Mick Woltman, as you mentioned, LSP engineer extraordinaire and
Appreciate
rocket
that,
guru.
Daryl. Appreciate that, Daryl.
So far, it's good to have you back into the broadcast booth for another
Just gonna
launch.
grab a bit of
So
coffee
far,
here, guys.
So good.
So far, so good. We just entered the T-4 and holding. This is a 30-minute built-in hold where the team is gonna, look at the vehicle and finalize last-minute preparations as we head down to T0 this morning. So the team's done a great job. Been on console for several hours and has gotten this rocket ready to go. So looking forward to this.
That shot from the ground there, looking up at the rocket, you can
I'll
see
be
the
right back, one
skies are
second.
blue. We've got some clearing throughout the day. Started off windy and a little overcast, but there you see the clouds moving across the pad. Very light, very scattered. Now we want to tell you where we are. We are in the nerve center of where launch is happening. We're going to turn around in our seats and wave at the camera. We're up here on this second level, but down below on the first level is the launch team, and you can see the 3 levels there, the 3 rows. This is where all the action is happening.
Yeah, this is the United Launch Alliance team. This is their launch control center. And Daryl, as you said, this back row that's closest to us, this is where the launch conductor, Dylan Rice, is sitting, along with his assistant launch manager, the anomaly chief, Dave McFarland, and our red line monitors, who are monitoring all the telemetry and everything on the vehicle and on the ground. In the middle row, you have the team that is working both the first stage booster and the second stage Centaur propulsion teams there. And in the front row, you have flight control and electrical systems that are monitoring the guidance nav, avionics, and all the electrical systems on the rocket. So as you can see, a lot of team members from United Launch Alliance to work this Atlas V.
And they've been quite busy for the past few hours, making sure that the fueling operation has gone smoothly. And they were also on console yesterday, Mick, when we rolled this rocket from the vertical integration facility to the pad. We got a little video there, and you can see there it is, the Atlas V coming out, all 200 feet tall rocket coming out of the vertical integration facility and rolling about a third of a mile out to the launch pad. Nick, you were out there. Pretty smooth operation.
Yeah, it was. The team did a great job making that trip about 1,800 feet to the pad, traveling about a half a mile an hour on the mobile launch platform and everything there. And team did great getting that out there and ready for RP1 tanking and then launch today.
You look at the rocket there, and it carries a special dedication today. Mick, it holds the name of a former ULA employee by the name of Mark Tim. Mark started his long aerospace career with the Boeing team in 1987, but after a decade in Denver, Colorado, he transferred to ULA's facility in Decatur, Alabama. That's where Mark Tim supported the ULA's fleet of rockets, including the Delta II, Delta IV, Atlas V, and Vulcan. There you see him in the middle, surrounded by NASA astronauts. Mark Tim passed away in 2020, and he's missed by all those who had the pleasure of working with him during his 30-year career in aerospace. And Mick, you knew him.
Yeah, I got to know Mark when he was in the Decatur facility, and I'll tell you, he was an extraordinary person. The team will miss him, and our heart goes out to the family and everyone that worked with Mark. He was a great guy.
And just wrapping up, we are on time and on schedule for a 4:38 p.m. Eastern Time launch of this Atlas V rocket. A beautiful shot from a drone there. We are ready to roll. We'll have the LSP NASA Launch Manager poll here in just a few minutes, but for now, back to Megan.
Thank you both. And now for a check on the weather, here's Launch Weather Officer Arlena Moses from Cape Canaveral Space Force Station's 45th Weather Squadron. Arlena, this launch weather you're about to report out, forecasted with data from GOES satellites, right?
Yes, that's correct, Megan. In fact, right behind me is a great example of the type of imagery that we get from the GOES satellites. In this case, because we're here in Florida, this is from the GOES East satellite, giving us a great view of what's going on across the Cape and East Central Florida this afternoon. Now, as mentioned earlier, we did have quite a bit of overcast clouds and some low clouds out there earlier today, but as our satellite imagery is showing, we've scattered out pretty nicely with only
Looks
a few
good.
clouds as a
Let's
concern
go.
as we go
What's up,
through the
Snap? How you
remainder of
doing?
the launch countdown. The trade-off, however, for those clearer skies and partly sunny conditions is that we do have pretty breezy conditions out there. Sure, anybody who's outside across the Cape this afternoon is experiencing. And those are going to be our primary concerns as we go forth into the count for the remainder into the launch. Now, if we take a look at the forecast here, we're going to be looking at those pretty gusty northerly winds from about 26 to 32 mile per hour range. Temperatures about on point for this time of year here in Central Florida, where temperatures are going to be in the upper 60s to around 70, which will feel a little bit cool if you're outside with that, but for launch concerns, not a big deal. As I mentioned earlier, liftoff winds are going to be our primary concern, with a smaller concern for some of those passing cumulus clouds. But overall, we have an 80% go for weather, and things are looking good. And so hopefully a good launch. Keep our fingers crossed. Back to you guys, Megan and Kevin.
All right, you said fingers crossed. We're doing it. Hey,
Yeah.
where are your fingers? Okay.
There we go.
Arlena, thank you again. Quick check of the clock. We are now at L minus about 28 minutes to go before we launch GOES-T. Now, GOES stands for Geostationary Operational Environmental Satellites. Geostationary refers to where and how the satellite will orbit the Earth. So this might be a little difficult to understand unless you see it, right? So this is why we brought some props here today. Kevin, let's start off by just talking about how you determine a satellite's orbit.
So it's really determined by its overall role, right? What is the job of that particular satellite? So in the case of polar orbiters, they typically will rotate along the poles, and their job is basically to image the entire planet as the planet rotates underneath it. So there is a time frame for which they can provide you a global image. And so again, in a low Earth orbit, that is why you'll see those particular satellites used.
But a geostationary orbit, it has to be in a fixed place. So in the sky at all times, right?
Correct. And actually, to achieve that, you have to be 22,000 miles above the planet. And as a result, so it can actually spin with the Earth as it continues to rotate. So relative to your position on Earth, you will always see this particular satellite in its place.
So that's why we say it will keep continuous watch over the Western Hemisphere with a second GOES satellite, right?
Absolutely. So between the two of them, they'll be able to cover this portion of the hemisphere we're talking about, from Western Africa all the way to New Zealand.
All right, and GOES-T will reach that geostationary orbit on March 12th.
Well, fact.
And now let's take a closer look at the satellite. GOES-T is the size of a small school bus and weighs over 6,000 pounds. It has a 5-panel solar array, which you see there. It's the one that's kind of swinging out. They'll produce more than 5,000 watts of energy, which is the same amount needed to power your home's central AC system. GOES-T has 6 advanced instruments that can analyze weather hazards and environmental conditions. The plan is for GOES-T to replace one of 2 GOES satellites already in orbit that together protect more than 1 billion people in the Western Hemisphere.
3, 2, 1.
NOAA is about to launch a new satellite into orbit above the Earth. This satellite will be the third in a fleet of NOAA's latest generation of geostationary operational environmental satellites, called GOES, the most advanced weather observing and environmental monitoring system in the Western Hemisphere. GOES satellites orbit 22,236 miles above the Earth's equator at speeds equal to Earth's rotation.
Yeah, and mana.
This allows for continuous coverage of weather systems as they move throughout the atmosphere. The GOES satellite system keeps watch over more than half the globe, from the west coast of Africa to New Zealand, and from the Arctic Circle to the Antarctic Circle. Each satellite...
Guys, we're about 30 minutes out. Yeah, actually less than 30 minutes. Here, let me, there's other stuff here. How about instead of that, we throw this on here? I mean, we'll keep the live stream going, but I figured you guys would want a Tory talk. A Tory talk with Dr. Thomas Buchan, the head of NASA's Science Mission Development Science Mission Directorate. He's a very good guy. Here, listen.
Hi, this is Tori. I'm at the ASOC, the Atlas Space Operations Center. And behind me in the distance, you can see the mighty Atlas rocket on the pad. Today, we're going to be launching a NOAA mission, the GOES-T weather satellite that is part of NOAA's great constellations of highly advanced weather satellites that help us better predict the weather, anticipate tornadoes, lightning storms, even track hurricanes more accurately. A life-saving mission. Now, let's go to the pad. I'm out here at the historic Slick 41 with our mighty Atlas rocket, getting ready to do an important mission, satellite that is a weather monitoring system that is so important to our country. And I am here with my good friend, Dr. Thomas Zurbuchen from NASA. So Thomas, what do you think about this mission?
Oh, GOES-T is the third in a series of 4 that is really providing value each and every day. We do a lot of missions here, and we've launched a number of spacecraft. This is the one that most protects lives on Earth here, and especially in the United States, and provides value to so many because of its weather forecast, also because it's fire forecast and mitigation type of issues, lightning detection, as well as space weather. We, of course, remember that the majority of spacecraft in orbit right now were not in orbit at the last solar maximum, the solar maximum that's starting right now. I know you're an observer of the sun, so you know it's getting more exciting, but of course, we need to get to space first. How do we do that, Tori?
Well, this is our Atlas V in its Dominator configuration, which is the 4 solid rocket motors. So it's a 1,000,002-pound rocket with its 5,000 kilogram spacecraft, but we're going to generate 2 1/3 pounds of thrust. So Thomas, don't blink when we say ignition. That rocket's going to be pulling a G right off the pad. And then we're going to go on a special enhanced GTO transfer orbit. So normally if this were like a commercial launch, it would be quick 2 burns in LEO, and then you'd be off on a big elliptical transfer orbit to the GEO belt, and the spacecraft would take quite a bit of time to circularize itself. But for you, we do the improved GTO, which means we're going to hang on to you for a long 3-hour coast. And when we're all the way up at geo altitude, we're going to burn again and lift that perigee way out to what is basically a medium Earth orbit altitude, so that by the time your instruments are calibrated, you can easily be out there at your geosynchronous orbit. A very cool mission, and now we got to do it. So it's go Atlas, go Centaur, go GOES-T.
The only G I see here is Tori Bruno. See that suit, man? See that suit? The only G I see right here. The last few seconds hurt. How do they make something so ridiculously cringe? I don't understand. How is that even possible? Anyway, we're 21 minutes out, fellas, from the GOES-T launch. So let me give you, if all that flew over your head, like the satellite's going to in a second. Yeah, speaking of cringe, I know. So GOES-T is it's a weather satellite, basically. It's a constellation of weather satellites operated by NOAA, the National Oceanographic and Atmospheric Administration. NOAA works very close with NASA and ULA in this particular case to launch these weather satellites. And NASA, they monitor them with NASA. What do these satellites do? What do they do? You ever watch the morning news? See the weatherman going, "Oh yeah, it's 68 degrees in our fair city, and it's 42 degrees in the Middle East." Sorry, Anchorman. Those are the satellites that they're using. These are the satellites that the weathermen use. These are meteorological satellites. They're not just used for like monitoring climate and stuff. They're the ones that tell the weather. Not weather, nice. They're the ones that tell the weather. Now, why is that important? Well, it's not just, the weathermen interpreting the meteorological data and then on a newscast telling you the wrong data, because they usually get it wrong. I'm from Boston. They always get it wrong. No, they're all right. The meteorological data is used for like monitoring the climate and stuff, to see what the climate's up to. There's also aeronautical meteorology, so like they got to tell the airports where the wind's coming from, what the weather's going to be like for the airports. Every single airport needs a weather forecast, so these satellites are doing much more than just like monitoring the climate. They do a ton of different things. A hurricane prediction, yeah. Here, there's actually the NASA stream. This is what these GOES satellites look at it. Whenever you see this on the weather forecast, it's a GOES satellite. There's a bunch of them up there, and they're in geosynchronous, so they kind of just, this is what they were trying to say during the cast. So the Earth's 24-hour period, right? So the Earth spins one revolution every 24 hours. Now, with satellites, you have what's called an orbital period, okay? So what's the orbital period? The orbital period is how the orbital period is how long it takes to do one orbit. So if you launch a satellite into an orbit where the orbital period matches Earth's day-night cycle, it'll appear to kind of hover with the Earth. It'll stay with it. It'll stay fixed. It'll appear to stay fixed over a position. In reality, its orbit is just synced, but it'll appear to look like it's just kind of sitting there. And that's, once again, that's what they were trying to explain. Now, what's the characteristics of an orbit like this? 23, between 22 and 23,000 miles that way. That's what, like 38,000 kilometers or something? I think that was off the top of my head, so that could be wrong. They're very high up, and they have a very, very low orbital speed because they're so high up. I like your accent. Oh, thank you very much, Grand Poobah. Yeah, so I could switch up the accent if you want. I don't want to talk like Dr. Z the entire time. We can absolutely do that. We could have looked like rock stars here, Tori. Instead, we looked like a bunch of wankers. No, so Sponge Boy me Bob. Sorry. So yeah, these are really cool. These are really cool launches. Now it's launching on an Atlas V. That's what Tori Bruno was saying. This is at 541, I think. 35,786 for Geo. There you go. Grab. Nice. I don't need no gosh dang weatherman to tell me the weather. I look out the dang window. Yep. You just need to do a Space News segment talking like Kimmy the entire time. Yeah, here, Vanker. Suddenly total. No, Mikey. No, Mikey. This is so not right. New Drive to Survive coming out soon, by the way. Anyway, so yeah, that's what these satellites are. They're the satellites that the weathermen use. You know, these are pretty important because that volcanoes. Okay. Oh, it's getting kind of hot. It's getting kind of hot there. Oh, yep. No, that's a little warm. Yep. Okay. Yep. These guys. I think that was a forest fire. How dare you? Yep. See, there you go. That's what they do. There's a constellation of satellites so they can see the weather pretty much anywhere in the world. Yep. See that? There's the polar vortex right there. I think that's what that was. Weather guy, double check me just to be sure. Oh, yeah, see? There's the forest fire. That's so interesting. Look at that. I mean, not happy about what it is, but it's really cool to see it from up here. Gives you a perspective that you're not going to normally see. No, that wasn't a polar vortex? Okay. Nope. So what was that? A cold... That would have been a front coming down from the north, yeah? Cold front, I'm guessing, because it's cold up there. That was just some random cloud feature? You're a random cloud feature. All right, cool. Thank you. I appreciate it.
Sophisticated technology to track wildfires in the western U.S., as well as detect lightning that can ignite a wildfire in parched vegetation.
This current capability of GOES is the fact that we can do rapid scans, higher resolution with higher sensitivity, and include things for the first time like Lightning Mapper and the ABI instruments. I don't think we could imagine not having GOES capability. We absolutely need it.
The National Interagency Fire Center is the nation's support center for wildland firefighting.
GOES is an eye in the sky. It's giving us a hemispheric perspective with GOES 16 and 17 without having those two satellites up there constantly staring, constantly monitoring, constantly providing us with information. We really have just a big gap. We would lose a lot of our capability to understand the environment, to see the interaction of the fires with the atmosphere and see how the atmosphere is impacting the behavior of the fires. With those being able to look at the United States every 5 to 10 minutes, we're getting a much more real-time appreciation for how fires are behaving because of the ability of the GOES satellites to detect the heat from the fires.
Kevin, we were talking earlier, and you told me that oftentimes GOES satellites, even at 22,000 miles above the Earth's surface, they can sometimes detect fires before people on the ground even know that they're there.
Absolutely.
That's so impressive.
It's an amazing capability, absolutely. And we heard from our National Weather Service rep, I mean, right there, that's a great example of how it happens. National Weather Service meteorologists are able to view an area that's not populated, but they can see a heat signature and actually detect that fire. And we found out to the tune of 80% of the time, they're the first ones to actually call and let fire responders know that there's a fire that has just started or is ongoing.
So we know GOES satellites can help National Weather Service, fire officials, as we've said, but I didn't know this, that we use GOES satellite data every day.
Every single day. Anytime you open up your phone and you want to see the forecast and you're opening up an app, a weather app, that's exactly what you're doing. You're actually using GOES information. That GOES data is going directly into the models that inform you on what the conditions are going to be.
Fascinating. I can't. I had no idea. Here I am just looking, and you never think about where it came from. So thank you so much for telling us about that. We're now L- about 14 minutes away from launching GOES-T. Daryl and Mick, it's about time for that launch manager poll you talked about.
It sure is. And before we get to that poll, which is happening at L-13, so just about 50 seconds from now, we got an update from the launch weather officer. You can see on the bottom of your screen the weather briefing there, right there. They talked about the winds.
It's just
They're
the weather
still
service.
pretty up, but the clouds have dissipated, so we are now at 90% go for launch, improving from that 80%.
Ilya, over here, dude, it's a little bit different. NASA and NOAA are state-owned, but they're not like... it's not for profit, dude. Something like NOAA or NASA operates at a loss. It's not a state corporation. We don't actually have anything like that over here. NASA, NOAA, like the firefighters that they were showing, that's all tax dollar funded. And so it's not, they released this data for kind of the betterment of everybody. That's the whole point. It's not like it's not like they do things different over there. So this data is available for anybody. You can look it up if you want, just like you can look up NASA technical documents if you really want to. It's kind of just public domain. So there's not really any profit, but also that doesn't necessarily mean that people aren't being paid to launch the satellite. ULA is being paid to launch it, and also it doesn't. This feeds into other things like the airline industry, and there's money to be made back off of that. But yeah, it operates at a loss, dude. I mean, NOAA doesn't make money. Hey, Jensen, what's going on? But you got to remember, these government organizations, of course they operate at a loss, because NASA and NOAA, the scientific understanding out is what your profit. That's what your profit is. You're putting in money and you get science out of it, dude. So it's a little different. It's a little different than like a state-owned corporation. Yeah, anyone can get at NOAA stuff, even from other countries. It's one of the things I think we do really well. That's what NASA's all about. Just leaving work. How you been? I'm all right. Which is why, so NASA's just a lot of money defund NASA. Zany, you'd be surprised how often people default to that, which I think is really, really funny. Amtrak would be the closest thing to a state-owned business entity. Yeah, pretty much, Orion. Yeah. Mm-hmm. Yeah, exactly. Ilya, it doesn't work like that over here. It's a little different.
And GOES-T is one of many NASA science missions underway right now. Let's head back to Leah to learn more about that.
Yeah, there you go, Zany. Yeah, right.
Hi, Megan. I'm here with Dr. Thomas
there's
Zurbuchen,
the guy.
NASA's
There's my
Associate
favorite.
Administrator for the Science Missions Directorate, and this is a huge year for you and your team.
Absolutely. It's a year of science. Every year is
Should
a
be
year of
pencil.
science, we say. Like we have an amazing number of launches ahead of us.
He's Swiss.
In fact,
For what it's
Tropics,
worth.
which is 3 launches. We have Maya, we have Emit, we have JPSS. And you see the theme, it's all Earth science related launches.
Absolutely.
Some of them in partnership. We also have Psyche,
Yes.
and then the first light of the James Webb Space Telescope, as well as many other highlights this year alone.
Yes, and so many of the missions that you just mentioned are actually tied in to both weather and the environment. Why is that important for NASA and the work that we're doing?
From the beginning, NASA was about exploring the universe, but also exploring and understanding our own Earth and providing service for that. And the launch today, as well as many of the launches in the future, are precisely about that, understanding our changing planet, the system of systems. Everybody we love is right here. Our entire history is right here on that planet. So we want to understand and help protect it as we go forward.
And so the information that we get from these launches, how will we use that?
So the information we get from
Karen.
these launches, we use to get a better understanding in many areas. Of course, understanding, for example, emit about the aerosols that are in the air. Where do they come from? We know they relate to precipitation in many areas. Like, how do they get transported globally? Maya, my daughter has asthma. It's about pollutants, learning from space, how to predict those and provide information for my daughter and the many others that suffer from asthma and so forth. That's precisely, each of them has an application like that, set of understandings that we want to bring to the table.
Complex science has a very simple application here on life on Earth, for life on Earth. So we also heard that the information that we're going to be capturing from these satellites is going to be available to the public as well.
Absolutely. Everything we do here in Earth science and all over the science portfolio is information that is made public. We want scientists of all training levels, learners of all ages, to be able to look at this. But we also believe it's really important to trust the science. You should be able to look it up yourself and understand it. We think that's a really important part, and we've led that. We're actually moving from open data to open science. So we actually even make in the future the codes available that provide the actual predictions and the information that is there.
It's incredible using this information in conjunction with other information to give us the best picture possible. Dr. Zurbuchen, thank you so much for joining us today. We're looking forward to this launch. I'm sure that you are as well. We really appreciate you being here.
Thanks so much, Leah. Absolutely.
Megan, we'll send it back to you.
Thank you both. And now taking us the rest of the way of the launch countdown is Daryl and Mick. Guys, take it away.
All right, thank you, Megan. L-7 minutes and 50 seconds until liftoff. Welcome back inside the Atlas Space Flight Operations Center. The launch team right behind us working this launch, and so far things have looked really good and sounded good over the nets.
Yeah, everything sounded great. The team is continuing to finalize their work as we get ready to pick up the count at T-4 and sync up the L clock and the T clock. We're coming up on that launch conductor poll at L-7 minutes with Dylan Rice, so I'm looking forward to hearing all goes from the team to get GOES T on its way.
You can look at the bottom of our screen. You can see the milestones as we count down to liftoff. We are coming up on polling, which is at L-7 minutes. In just a few seconds, we're going to pull up the poll on the right side of the screen and count it down.
7 minutes.
Okay.
Status check to proceed with terminal count. Atlas systems. Propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2.
Chat.
Go. Water. Go. Centaur systems. Propulsion. Go. Pneumatics. Go. LO2. Go. LH2. Go. ASGAS. Go. Electrical systems. Airborne.
Go.
Ground. Go. Facility. Go. RFFTS. Go. Flight control. Go. GCQ. Go. Operation support. Go. COM. Go. Umbilicals. Go. ECS. Go. Redline monitor. Go. Quality.
Discovery.
Go. Op safety manager. Go. ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief. Go. Range coordinator.
Clear to proceed.
Cheers, spot.
You have permission to launch.
AFD. 12 months.
Proceeding with the count. ALC. Verify T0 is set for 21:38 Zulu. Verified.
ULA launch conductor Dylan
6
Rice
minutes.
getting green across the board.
Yeah, that was great to see Dylan choreograph that poll, the culmination of several hours of work by this launch team, and then hearing launch director Tom Heater from United Launch Alliance giving that ready to proceed for launch today. So very excited and happy here to hear that as we get ready to pick up the count.
As we look outside at the rocket, we can see those blue skies. The clouds are moving a little bit, very slight amount of clouds. You don't see it here, but we're looking at blue skies. You can see some of them there. They're moving. That's representative of those winds. But as we know here in Florida, it's such a beautiful time of year in March. But Mick, 3 months from now, it'll be the start of hurricane season, which is a concern for Florida and everyone along the Atlantic seaboard and in the Gulf states.
Yeah, and I'll be very happy to have Goes T up there in the west, as Kevin was saying, you know, all weather moving west to east. So getting Goes T into proper position to follow those weather activities
little windy down the Cape today.
Great asset
Those clouds
for
are
everybody
low,
from
too,
a personnel
guys. They're very
safety
low clouds.
standpoint.
And the public really relies on the public broadcasters who come out and give us that information about what's going on. And we have one of the more popular meteorologists that you may have heard of sent us a pre-launch message. Take a look at it now.
Hello, everyone. I'm meteorologist Jim Cantori from the Weather Channel Television Network, and I am so excited for the GOES T launch. Meteorologists and weather anchors like me across the country depend on GOES data to bring you your daily weather forecast, but also to keep you and first responders safe during severe weather events. Accurate and timely forecasts are crucial, and that's not possible without satellites like this one. Godspeed, GOES T.
So, for
3, 2, 1, mark.
4-minute count has been released. All right. We're in terminal count here. Who is that guy for people overseas? He's this he's a meteorologist that works for the National Weather Service. And like if there's tornadoes and hurricanes, he goes to the tornado and he does his Jim Cantori does his like meteorological predictions like in the middle of hurricanes and tornadoes and all this other crazy stuff. He's pretty cool. He's pretty cool. Pretty cool dude. In Oklahoma, his car flipped in a tornado. Yeah, no, he like goes drive like. Have you guys ever seen Twister, the movie Twister? That's what Jim Cantori does. He's kind of nuts. Kind of nuts, dude. All right, I'm fast forwarding to get us all synced up here. We're inside of the terminal count here. Cow, another cow. We got cows.
He's from Northrop Grumman.
Right.
We'll provide
Here we
a
go.
little extra performance
good day to
and
launch.
get Goes T on her way.
You
Jim
hear
equals
the team
run.
really picking up the chatter here as we get down to the final minutes.
That's cool, man.
For the launch of GOES T on board an Atlas V rocket from right here at the Cape Canaveral Space Force Station.
Yeah, Daryl, we heard the team. They secured the Atlas tanks to flight pressures, secured that topping. So we see that the liquid oxygen on board that first stage is secure and ready to go. We should be hearing them at about 1:50, securing the Centaur tanks and getting that tank up to flight pressures, getting ready for launch.
Spacecraft is on
T-minus 2
internal,
minutes.
getting ready to listen to the vehicle.
154?
155.
No, 154.
Launch sequencer start.
Okay.
150.
Securing Centaur LH2.
Securing Centaur LO2.
So there we hear Daryl, vehicles on internal. The auto sequencer has taken over and started
140.
the count.
What was
And
that?
Centaur LH2 and LOX
137.
sequences are done. Launch has been enabled by the launch conductor.
FCS armed.
The flight termination system has been armed.
A little bit of ice
And the
came off
team
the
is
booster
continuing
there.
to finalize all preps as the vehicle is getting ready for liftoff.
120. SCS count started. 115. Reduce ECS for launch. Roger.
Environmental control systems.
110. Vent valves locked.
And there we hear the vent valves locked, securing everything to secure that boil off. We should now be coming up on the last call for the range.
60
1
seconds.
minute. Rock, report range status.
Range green.
There's a lot of
There
ice
we have a
coming off
green
that
range, Daryl, so everything looks good this morning. Last but not least, we will bring everything to flight pressures and then hear that last status check from Dylan Rice.
And that'll be an exciting moment indeed as we look across the river there to a shot of the rocket. Just a few
40
seconds
seconds.
left.
Across the
Stable
river.
at step 3.
That's the ocean, homie.
And there we verified that all pressures are good, and we are stable at step 3, ready for liftoff this morning.
T-minus 30 seconds.
28. Verify ECS reduced for launch.
Verified.
25. Status check. Go Atlas. Go Centaur. Go Goes T.
That's the
And
best
here
part,
we
dude.
go.
T-minus
The
10.
final seconds now. 10, 9, 8, 7, 6, 5, 4.
Sound suppressor
3,
is on. Stand by
2,
for engine ignition.
1. And liftoff.
Everything looks good.
Liftoff of NOAA's
Go, baby, go!
Our newest weather sentinel in the sky to help keep us safe here on the ground.
Okay, pitch over.
Let's listen in as we listen to.
Oh, yeah. What a pretty rocket.
Who's the flight mission commentator?
View has gone to closed loop control. The RD-180 is now throttling down as expected. Engine response looks good. We are now 33 seconds into flight. Atlas is 3 miles in altitude, 0.9 miles downrange distance.
Nice picture.
Max Q, 48 seconds.
What's closed loop control?
We have passed through Mach 1.
Closed loop control means it's...
The vehicle is now passing through max Q, maximum dynamic pressure.
Closed loop means that the vehicle is using internal guidance.
Now 55 seconds.
It's not using GPS or antennas to geolocate itself. It knows where it is because it knows where it is. That's what the missile thing is about, closed loop guidance systems. Past maximum dynamic
RD-180 is now throttling back up.
See the Banana River back there and the NASA Causeway.
We backed off the throttle to reduce
Now
the
at
thrust
75
of the
seconds
rocket.
of flight, Atlas is 13 miles in altitude, 10 miles downrange distance, traveling at 2,700 miles per hour. Now at 90 seconds into flight, ULA's Atlas V rocket weighs now just 1/2 of what it did at launch, burning propellant at a rate of more than 2,600 pounds per second.
Oh, something came off.
In 10 seconds, those solid rocket motors on the side will cut off. Beautiful shot from space.
Okay.
SRBs have burned out as
Jettison
expected.
1, Jettison 2.
And we see a good SRB jettison.
Clear
Okay.
shot of those
Vehicle's now-
SRBs.
Hey, what a shot! Nice. You see those SRBs flipping out over there?
Here in a few seconds, they're going to throttle back up.
Vehicle performance looks good at this time. Now 135 seconds into flight.
Okay, everything looks good here. That's funny, Squishin, but it's also not funny, so.
The RD-180 has throttled down slightly.
The RD-180 is throttling down to reduce G-load on the vehicle because the vehicle is
Vehicle performance continues to look good at this time.
it doesn't have as
Tank
much
pressures
fuel
are
in it.
stable,
So
and Atlas booster battery voltages remain in their expected ranges.
if the RD-180 is producing the same amount of thrust, you know, with
Now the upper stage is preparing for its use. Centaur reaction control system is now pressurizing to flight levels.
the RD-180 stays they throttle down because the fuel's going down to make sure that the G-load doesn't break the fairings. You don't want to accelerate too fast. You can accordion the vehicle.
Now they'll jettison the payload fairing, which protects GOES T at 3 minutes and 30 seconds.
Rocket guy, the ice is coming off this vehicle in a way that I haven't seen before.
It's
Maybe
just
ULA
over 1
tried
minute until
something new.
BECO. We're now seeing the RD-180 throttle limiting to maintain a 2.5 G acceleration limit.
See, they're maintaining limits because they don't want to exceed
Standing by
load
for
limits
payload
on the
fairing
Centaur.
jettison.
The upper stage on these Atlas vehicles are very delicate. They can only withstand so much compression load. But see, oh, there goes the fairing. All right.
And we've seen a successful payload fairing jettison.
Stand by for FLR jettison. There's the FLR.
Good
Bye
shot
bye.
of those fairings.
Forward load reactor, guys. So what does that forward load reactor do? That's part of the reason why
RD-180 is throttled back up now.
Centaur is so delicate. The Centaur is actually connected at the top and the bottom, and the fairing goes around it with this type of Atlas to make sure that the Centaur doesn't compress too much.
4.6 G acceleration limit, and will maintain this level through BECO.
See, the forward load
And we're
reactor
looking
was
at
attached
animation
right at the
now.
top there.
We've seen that the Centaur has begun its boost phase chill down sequence.
Easy. I've seen some things on this launch that I haven't seen before, but I don't know. 4C
Booster about to cut
acceleration.
off.
That's a little bit faster.
And BECO, booster engine cutoff.
Okay, separator motor.
Standing by for stage separation.
There we go.
And a
Centaur vent
successful
right there.
stage separation event.
Okay, they'll start to trickle the propellants into the Centaur to get the
We've
expander
seen
cycle to
pre-start
turn
on
on.
Euro 10.
That's the pre-start sequence. Okay, she's good.
And mass 1. We have ignition for the first burn.
Main engine start 1. Centaur's doing its thing.
This
There's the
first burn
gimbal.
of ULA's Centaur upper
Look
stage.
at the gimbal.
will take
Oh,
the
that's so
spacecraft
cool.
into a parking orbit around the Earth.
Fly,
burn will
baby,
last just
fly.
over 7 minutes.
What a shot there, huh, Mick?
Yeah, that was great, Daryl, to see all that and listen to Rob Kesselman call that
Centaur's
flight.
Aerozine 50 monopropellant systems
First
are
stage
rolling the vehicle
performed
over.
very well this afternoon, and everything's looking good. Those Jims.
Activity on the reaction control system as it begins its periodic firings to maintain thermal control conditioning.
Yep. They're slow rolling the stage.
Yeah, those Gem 63s performed well, solid rocket
Basically
boosters,
barbecuing
and
it to make sure
RD-180
that
performance well. What I really liked was when we saw the payload fairing come off.
What they're doing right here, guys, is they initiate a slow roll. So the roll rates are a little bit higher. What does that mean? So they're basically, if you notice, this thing is slowly rolling on its long axis. What does that do? That ensures uniform thermal on the vehicle. They don't want one side of the vehicle getting too hot and the other side getting too cold. You basically want uniform temperature on the whole thing. And now that's easy to do when it's down here, right? But when it's up in space, the side that doesn't have the sunlight on it is really freaking cold, and the side that does have the sun on it is really freaking hot. So they initiate a slow roll like that to make sure that you get uniform heating. That Centaur is venting a lot.
But in the meantime, we'll send it back to Megan out the hostess.
It's like cooking a rotisserie chicken.
If you're just joining us, welcome
Same thing.
live to Kennedy Space Center in Florida, where we just saw GOES-T launch from just behind us at Cape Canaveral Space Force Station. And guess what, everyone? I just found out that this was Kevin's first launch.
It was.
How was it?
It was super exciting. Almost a proud moment as an American, 20-year Air Force vet. And
my guy.
To be able to see this was awesome. Absolutely awesome.
Yeah, I'm so glad to be here. It was very fun to watch you react. Like you were like you were like a kid. Like I have to take this. Oh wow, it was great.
Absolutely.
It was great. So what's next for this mission?
Well, the wonderful thing about this, now that we've had a successful launch,
fellas, I haven't seen Centaur do that before, but it could just be because it's backlit by the
that's
sun.
When we'll start our checkout phase. We'll be looking for the
John.
data to come down from the spacecraft to make sure everything checks out, that the images are correct, all that kind of stuff has to work its way through.
And GOES is NOAA's latest weather satellite. As
Just
we've said, we've been launching GOES satellites together for nearly 50 years. I mean, there's been so many advancements made in between those times.
There have.
Okay, so I'm just looking at the telemetry up here. So this is a graphic, obviously, of what the vehicle's doing, but this is a graphic showing that's interpolating real-time telemetry. So if you look up here, we're looking for about a 27.5 degree orbital inclination insertion here, and it should be. I don't know if they're gonna do. So we have MES1, MES2, MES3. So this should put it just into parking orbit there, and they got rid of it because Melroy. All right. Here, I'll put this on. I don't see your last weather guy.
Of it as you see it lifting into the heavens. It's always exciting.
And hours and hours and months and months of work that go into it. Absolutely. So NASA's vision is to expand knowledge for the benefit of people here on Earth. That's the heart behind everything that we do. How does this mission fit into that?
This mission is
I
a
haven't
great
seen the ice
example
come off of that booster
our
like
mission.
that, Sile.
In a lot of different ways.
Saw it come
I
off
think
like
one
that
of the
before.
most powerful things that we do at NASA is we partner with others to maximize the benefit of the things that we do. So this mission to launch the GOES-T satellite will enable us to have cutting edge capabilities that are looking down on the western hemisphere, the western part of the United States, to ensure that the data that goes into the NOAA models around weather are optimized, they're up to date, they will affect people's lives, whether it's farmers or protecting from wildfires. But what's interesting is we're also going to take that data because we have Earth scientists who are modeling our Earth as a system and climate far out into the future. This isn't an operational weather, which is what NOAA's mission is. They do it very well. But we take this data and we also use it for the benefit of science. So it's a really synergistic partnership.
And you just mentioned climate change and monitoring the changes because that is a priority.
It's a little windy.
It is. It's one of our top
Pam's
priorities.
like, damn it.
We are already doing a significant amount in this area. Earth science and looking at our own Earth has always been an important part of our science mission. Interestingly, we also study other planets in the solar system, such as Mars, which we believe was once wet and had more of an atmosphere. And so the question is, how did it get the way that it did? And how do we make sure that does not happen to our planet? So it's a critical part of our mission.
Well, we're hoping that the information that we get today can feed into the future missions of tomorrow. If nothing else, we'll certainly know the weather. Pam, thank you so much for joining us today. We really appreciate it. And
So that's Pam Melroy. That's NASA's deputy administrator. She's, I think she 3-time shuttle pilot, if I'm remembering correctly. She flew the shuttle, and I'm not talking like riding right seat. I'm talking about commanding the space shuttle and actually landing it on the runway and stuff. Pam's cool. Really, really, really cool person. All right. Who is NOAA? The National Oceanographic and Atmospheric Administration? They're an Earth. They're climate monitoring. So they should be looking for about 27.5 there, and they took the telemetry away. 27.5 degree inclination at about 200 kilometers circular. That looks like the Tonga volcano, but I could be wrong. Covering today's NASA press event after the launch. What press event? 92, 112, and 120. Yeah, hell, Hydric. Good stuff. Good stuff. I really wish they would just keep the telemetry going because I could teach you guys about the mechanics, but we have to not do that. At the risk of bumping into Rule 8, what you take to Zany, I don't know. When there's news to report, I'll report it to you. All right, so stand by for MES.
Normally we've heard pressures and everything look great.
EU system has gone open loop.
Okay.
Here in about 10 seconds, we'll have the
Standing by for the end of the burn. And we have MECO. Main engine has cut off.
There
500 by
that
170
completes
insertion
that
at 28.1.
And so now we go into about an 11-minute coast phase.
At this time, the GOES-T spacecraft and ULA Centaur upper stage are in an unpowered coast phase that will last approximately 11 minutes. The coast allows the vehicle to move to optimal orbital position in the orbit prior to beginning the second main engine burn.
And what you're looking at is animation that is tied directly to the
fire
telemetry we are
geostationary
receiving from the
transfer
rocket.
insertion.
Yeah, the team is using all the vehicle telemetry to look at and
The
power
reaction
this
control system is operating at the 100% settling mode at this time.
power this animation that we're seeing, which is really good. And as we heard Rob Kesselman say a minute ago, this approximate 10-minute coast, we're in this park orbit around Earth right now as we coast around to get into the proper trajectory we want to be for that second burn, which will then send us on our way towards that geostationary spot we want to be. It'll be a longer burn, and then we've got, Daryl, that long 3-hour coast that we're going to wait around for.
3 hours, folks, between the points on the bottom of your milestone list, between MECO 2 and MES 3, that's 3 hours. It's short there on your screen, but it's a long one. As you're looking at the animation, we are in orbital darkness. The sun is blocked out, and so the animation is reflecting that at this time, so we can't see the Earth behind it. They give it that kind of accuracy in terms of its look, so the spacecraft is in total darkness, but when it comes out and those solar rays unfurl, it'll have some power. All right, we're going to send it back to Megan for now, and while we coast, but we'll be back for that second burn.
Thank you both. Now, GOES-T will warn us about weather here on Earth, but also space weather. But what is that, and how does it impact us here on the ground? Take a look.
So the sun, looking here from the ground, seems very constant and quiet. But actually, when we look at it from space, we can see it's quite turbulent and active. Space weather is activity on the sun and in the near-Earth space that can affect our technological infrastructure and society.
Like Starlink satellite. Oh, wait.
The sun is constantly spewing out a stream of particles called the solar wind that goes out into the solar system. And it affects us here near Earth, where we're protected by a magnetic field. The interaction between the solar wind and the magnetic field can cause space weather.
Yep.
The Carrington event is the largest storm we've seen in recorded history when we're looking at space weather. But every solar cycle, which repeats about every 11 years, one estimate estimates that there's a 10% chance of getting a large storm like the Carrington event that could impact us here on Earth.
That's so ridiculous. So the sun, what you're seeing right there, guys, is basically the sun is a gigantic power plant. So it's this huge fusion, basically explosion that's going on, right? And the solar wind is, what I like to say is that the solar wind is its exhaust plume. Oh, geez.
That can damage electrical power grids that power our communities.
And those kind of loops that you saw coming out of the sun is ejecta from like a backfire. Like what I like to say is like the sun backfires, and when it backfires, it's a mass ejection out of the sun. And when you eject out of the sun like that, sometimes the mass ejections out of the sun get out of the solar corona, right? So that's called a coronal mass ejection, or a CME for short. Those CMEs blow solar winds around. They blow basically the exhaust cloud of the sun outside of the gravitational pull of the sun. Sometimes it's enough to shoot it out, all in all different directions, and that's what those pops that you see on the surface of the sun is. If it's strong enough, if the ejection is strong enough, it'll break the sun's gravitational pull and it'll come out towards us. When that ionic radiation, the exhaust plume from the sun, hits the magnetic field, the magnetic fields absorb the thing. But like there's parts of the magnetic field where that ionic radiation gets to and it reacts with the gas in our atmospheres, and that's what the borealis, the aurora borealis, that's what that is. It's the sun's exhaust hitting the gases from our atmosphere where the magnetic field can't absorb it. But like sometimes there was a CME right there. Sometimes the sun or sometimes the ionic radiation can heat up the atmosphere, and when it heats up the atmosphere, it can screw with satellites and stuff. That's what happened with Starlink the other day. There you go.
NOAA is working with its international partners to expand our observing capability. We're committed to observing along the Sun-Earth line. So we're going to do the imaging of the sun and the upstream buoy measurements of the solar wind along the Sun-Earth axis.
The sun backfires from time to time, just like any other thing.
The more we understand about the sun, the more we can prepare for it and become, just like we are a weather-ready nation, become a space weather-ready nation.
Yeah, see, the other thing is that...
And as we look forward to humans exploring out into the solar system and advancing...
See, this is the kind of stuff that Orion has to take into account. That's part of the reason why Orion is so damn expensive, because it's designed to go out outside of the magnetic field into deep space, and it's designed to operate out there for long periods of time. That's part of the reason why the price is high, because when you send something out there, it gets expensive. So, like, the other thing is that these solar winds can screw with the magnetic field, and they can move it around. That does happen. And this is the part I'm not too 100% on. I'm pretty sure I said that right, that it can screw with it, and it can move the magnetic field around. The magnetic field shifts, and if it shifts too much, then we got a big problem. That wouldn't be good. I'm pretty sure that would screw with the climate a pretty good amount.
Actually follows around and looks at one spot on the Earth, if you will, and then the JPSS launch is we call it a sun synchronous, so it actually stays at a certain sun illumination and does orbits around the pole many times to give us a different look at the Earth
shielding.
as
now,
it's
keep in
spinning
mind,
on its
fellas.
axis. And you take.
All right, hold on one second. Keep in mind, just because you're sending something out into a sea of radiation doesn't mean it should be made out of lead or tungsten. You wouldn't want to do that. That would be about as useful as making a boat hull out of spongy material. Remember, you don't want to absorb the radiation. You want to reflect it. Different materials can do that. Aluminum is really good at doing that. But you also got to make sure that you can't make your electronics out of aluminum, right? So you have to have rad-shielded aluminum sheath wires with copper underneath it. I mean, not exactly like that, but you need to basically rad shield anything, because the radiation can go right through stuff. You want something that bounces it like aluminum. Aluminum is actually really good. And that's something that they figured out from the Apollo program, that you can make spacecraft out of aluminum and it bounces that solar ionic radiation. It reflects it like a boat hull would push the water out of the way. Same idea. Now, does that mean that, like you could... Does that mean that you couldn't make a lead-lined spacecraft? I mean, you could. It would be heavy, but once again, that would be absorbing radiation. You don't want that. Down here, lead-absorbing radiation is what we want, because radiation doesn't really... I'm not going to say it doesn't naturally occur down here, because it absolutely does. But you make stuff out of lead to absorb all that stuff. Lead's a great moderator for radioactivity. Water is too. But once again, you want to bounce that radiation. You want it to reflect off of it. Right, you don't want it to absorb. So building a spacecraft out of lead or tungsten is not what you want. That's not a good idea. Aluminum does it very well. I'm not sure so much about anything else. I know that aluminum is the kind of the material of choice for bouncing this type of radiation, but so I can make my spacecraft out of water to protect people from radiation. I mean, if you wanted to launch a big inner tube into space, Jack, yeah, I don't see why not. Water lining it. Water's a great moderator for radioactive materials. That's why nuclear power plants, for instance, use it as a moderator. It's why we put the nuclear reactor in the water, or at least one of the reasons. So yeah, I mean, SpaceX tweet targeting Thursday, March 3rd for the Starlink launch from Florida. Gotcha. I don't know, Firework. I have no idea. I'd have to do more material science research. How do they start the second stage? Do they use T-Tab like SpaceX? No, Goalie, the RL-10 doesn't need to do that. The RL-10 is using an expander cycle. So basically there's pre-valves. There's pre-valves inside of the Centaur that trickle the propellants into the motor. That's how they pre-start an RL-10. Basically that really, really cold propellant hits the, warm engine, right? And that causes the propellant to expand into a gas. It basically evaporates. It evaporates into a gas because of the heat, and that evaporation and turning into a said gas feeds into the turbopump. That's called an expander cycle. And that's what spins the turbopump. It actually, they do it with hydrogen. The hydrogen goes through the rocket engine, right? Through the nozzles, the channels on the rocket engine, and then it goes into the hydrogen turbopump. And that hydrogen gas gets dumped overboard, or they could use it for film cooling, I forget. And I know that the power pack on an RL-10 has the input for the hydrogen, and the hydrogen, it spins the hydrogen turbopump, and RL-10s actually have a gearbox on them. They have a transmission, like a helicopter gearbox. And the hydrogen turbopump has a gear on it, and that gear is connected to another gear on another shaft, and that shaft has the LOX turbopump. The reason why they have a gearbox for this type of... Oh, there we go. There's the engine start.
All right, main engine start number 2.
Okay, so they're going to get this. They're going to get this number way high up here. This number will get higher and higher as they burn for longer and longer. They're raising the apogee of the orbit. The reason why they need a gearbox between the liquid oxygen and the liquid hydrogen pumps, fluid impellers, is because you need to feed fuel at differential rates. You need to feed a lot more hydrogen than you do oxygen because of how liquid oxygen, liquid hydrogen mix to make the fuel mixture that they need to make the RL-10 work correctly.
Hi, I need your opinion on something.
I'm covering a launch right now, baby. Can you give me a second?
Have ability to map lightning. It's got high technology on there that's very valuable.
Yeah, Roger. Expander cycles are really, really freaking cool.
It could have been suspect, rather, I should say susceptible. Susceptible to lightning when it was on the ground.
27.5 is what they should be looking for here. Look at that. It's going up big time. Actually, it might go beyond 27.5.
This is something that you do a lot. Go out
Easy.
there to the launch pad.
Oh, it's a favorite channel.
I was
Deepak.
invited to go out with one of LSP's young engineers to share and install this.
Yeah, they're putting it into a huge home and transfer.
Delays. Let's check it out.
So, oh, yep, and they're going to cut the telemetry. Yep, of course they are.
Hey, Alex.
Hey, Daryl.
Good to see you.
Good to see you, too.
Hey, thanks for having me out. So, this is it.
This is it. This is the PLI.
The NASA Portable Lightning Instrumentation. I see it right here. You're going to take it up there all the way where the top of the rocket is?
Yeah, right around where the payload fairing is, level 5.
All right.
That's where we're going.
Well, you need a hand?
Yeah, come help us.
now that we're inside the VIF and we're about 13 stories up. Tell me a little bit about this box. You've got some, looks like some sensors here.
That's right. So we got the current probe.
Just watch the clean feed for the telemetry.
And we have 3 more sensors over here. This one is an electric field sensor. This one up here is a magnetic field sensor. And this little one over here, that's a GPS antenna. That's how we get it, make sure our data stays synchronized in time, so that we can correlate that data to all the other lightning detection networks in the area.
So what happens if there's a lightning strike somewhere nearby? What does this do?
So if it's close enough to cause any interference in this area, these field sensors will pick it up first. And they'll cause the entire system to take a snapshot of that data and record it.
Whoa.
And how is that helpful?
We'll know what the peak of it was. We'll know how long the transient lasted. We'll be able to calculate how much energy traveled through there. We'll have a lot more information to work on.
Small box, big rocket, but it's got a big role in the whole scheme of things.
It's got a big job, that's for sure.
So we can see those lightning towers out there. And ULA tells me that that protects the rocket when the lightning strikes. So why do we need the PLI?
Yeah, so this system over here, we call that the lightning protection system. That's designed to protect it from a direct lightning strike. That means the lightning is attaching directly to the rocket. And we're concerned about, a lightning strike out there in the ocean, maybe, just a mile away. And the energy in a lightning strike is so intense, it creates these very powerful magnetic and electric fields. And those are the things we're concerned about. Because that magnetic field can come through and couple into the umbilical cable. It's a huge loop. It makes a big old loop, and that's the current we're looking for with the PLI.
Has the PLI ever prevented a long launch delay for a previous mission?
Mars 2020 was where the data from the PLI gave the spacecraft team the confidence to go ahead and launch.
So there was a lightning strike around the Mars Perseverance rocket.
That's right.
And you saw it?
And we gathered that data, yep.
And it launched on time.
It did. And it's up there now.
That's right, on Mars.
That's right.
That was actually
a lot of fun to go out there, and Alex, of course, was great to have me out there at the pad. But this technology, really helpful when you have a lightning strike. It was connected up inside the VIF when GOES was inside.
Yeah, Alex and the team have done a great job with that. They've been studying this for years, and they came up with this PLI, and working with our commercial partners, they've been able to install it, like you said, on the VIF for the Atlas V mission. And as Alex mentioned, we actually used it during Mars 2020 to help us verify some information, so we didn't have to go back and retest anything, and it actually saved the launch from delaying. So, the hardware is great for what we have involved in it.
Especially important for a planetary window like Mars, where you only had so much time to launch to make it to the planet. Well, we are in the midst of a 6-minute burn. We're about to wrap that burn up in just a few
You have
seconds.
gone to open loop control.
You're looking at animation of the Centaur upper stage.
Yeah, look at the
GOES-T
apogee now.
spacecraft as represented by animation.
Way
just a
up
few seconds
there.
left in this burn.
And we have MECO 2, second stage
right.
main engine cutoff.
And there you go.
There
We
you
have
got the
completed the
inclination down
second
to
burn.
25.6.
Really
RCS
got
is now operating at 100% settling level.
away from the Earth, and now we're cruising pretty good speed away towards that stationary point where they want to get that geostationary orbit.
Yeah, this is the moment we've been talking about a little bit, right? This is that 3-hour coast that we're going to have Centaur and GOES-T do their thing, head out towards that geostationary where they want to get to, so we can have that third burn of the Centaur. And what we'll see on that third burn, Darryl, is that after that 3-hour coast, Centaur will go through its process again of pre-chilling the engine, doing some things to get ready for that.
Centaur is now entering an extended duration coast phase. This coast phase will last approximately 180 minutes, where we'll have
ready for that final
third burn prior to spacecraft separation.
Yeah, so we've now flipped the bottom of our progress bar to a countdown clock to show you and represent that 3 hours. When we return, we should be out of Africa and near the coast of Australia.
These are monopropellant thrusters, fellas. That's an Aerozine 50. See these tanks right here? Aerozine 50 monopropellant. These tanks are what make those things work. They're actually monopropellant thrusters. They're shooting hydrazine into a catalyst to create an expansion event, or to create an expansion of gases to provide thrust. The Centaur with the RL-10 coupled with that Aerozine reaction control system is a it's capable of extremely precise insertion. So you could be very, very accurate with it. That's the reason why like people still fly with ULA. And now, don't get me wrong, I'm not saying that people can't, I'm not saying that other launch providers, other commercial entities couldn't be able to do orbits like this, but ULA with that Centaur stage is capable of extremely precise insertions from a very long way away. Like, they were able to get a burn right for like Perseverance. They got the burn correct with Perseverance, and the burn stopped when the thing was very close to Earth. They got the burn so accurate for the landing site for Mars that, yeah, they didn't really need to make many course corrections on the way out there. Doing a insertion burn, a transmartian injection insertion burn when you're at Earth and not having to do many mid-course corrections is a hallmark of what that Centaur stage is capable of doing. It's a very, 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 very good upper stage. One of the best flying around. I don't know, Penta. I don't know what the catalyst is. I have no idea. How big and strong are those? Centaur. Oh, and a little bit of a handover from the ground station there. DCSS versus wide-body Centaur. I'll take the wide-body Centaur, Pigzik, but they're both good stages. That's the same tech that the rocket crane uses, right? Hydrazine plus catalyst. The rocket crane. Not sure. Does having a catalyst to cause a reaction technically mean that there's more than one propellant? I know it might be semantic, but there's a reaction between two things happening, right? Of course there's a reaction between two things happening. You can't get thrust without that happening, hip-hop. And no, it's not semantic. Saying that it's a monopropellant thruster is semantic because it uses a catalyst. You got it the wrong way around. You're being the wrong kind of semantic. Centaur is really, really good. It's capable of putting stuff in orbit within like a 2 to 3 percentile of like planned mission trajectory, which is insane when you think about it. That's really, really good. And once again, I'm not saying that other vehicles can't do that. I'm saying that Centaur could get it more precisely on the first try than anything else flying. It's a very, very good upper stage. And Centaur 5 will be even better. That's right. So anyway, I'll keep you guys informed with the Ghost T stuff here. And I'm just going to take a second here. And I have other space news if you guys want to talk about that. I have some pictures of a new SLS LOX tank for Artemis 3 being made. But yeah, that was the Ghost T launch coverage. I hope you guys enjoyed it. It's fun. I'm just sifting through all this. There's some Formula 1 stuff that I wanted to show you about aerodynamics that I think people would enjoy. Hey, Red Panda, thanks for the raid. You currently have 666 viewers. Thank you. It's probably different now that Red Panda raided. Red, thank you. I'm going to duck out. We'll be back later. Make sure you don't goose, all right? Take a minute and see what Brimo wants. Yep. So let me see if we can just get a feed of what that Centaur stage is doing. Yeah, here we go. All right, I'll be back in one moment here, okay? Be back 1 second. Okie dokie. Yeah, she's, look at they're slow rolling that stage. They're barbecuing it. Oh, boy. From the Minecraft server, okay. What the hell is that? Kinda digging the chill. I never understood why they were rolling it. It's to ensure uniform thermal conditions on the stage. You don't want one side of this getting too hot, and you don't want the other side getting too cold. It'll boil off half of your propellants, T-Man, so you roll it to ensure uniform thermals on the vehicle. Dude, I'm digging that. I'm digging the NASA jams here. This is nice. Is that a koi pond fountain? Or your grandpa taking a leak? You hear that? Sounds like my grandpa taking a leak, Mikey. Mikey, 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 I got it! Oh, I don't got it. You clutch. Hope it wasn't a deposit bottle. What? Did the shuttle roll? No, Sunshine. The shuttle kept its thermal protection system pointed at the sun whenever it could. Of course, on the far side of the planet, that doesn't... On the dark side of the planet, that doesn't really make a difference. Stared at it, marveled at its beauty. Its genius, only you knew the power. Roasted spacecraft, sounds tasty. Tis. Alright, so how about we get into some space news here while that thing is out on its coast. I'll keep you informed with the coverage of the Ghost T launch. Pretty much, I mean, we'll be here for the rest of the day. So let me switch us over to the Space and Rocket review. Oh, speaking of, did you watch the race? I loved it so much passing. Yeah, those tires, though. I watched the highlights, Bandit. Brimo and I... Sunday is my only day to hang out with Brimo, and I want to do that, and it kind of sucks because we can't watch NASCAR, but I also want to hang out with Brimo a lot more than I want to watch NASCAR, so... Know what I'm saying? Orbex updates. The first link is from the first link is from February 15th. Second one is from today. Okay. So I'll keep you guys updated with what's going on with that. Let me they're related, which is why you linked both of them. Oh, nice. Centaur kebabs. Oh, now I'm hungry. I'm eating steak tonight. We have steak in the freezer. I'm making steak. Orion has a new project manager for a quick news thing. Well, fellas, there was a meeting about SLS this morning. I think it was a House Oversight Committee or something. As if there wasn't enough bad news going around right now. Let me see if I can find it. Jeff Faust over at Space News covered it. Let me see if I can go check out his tweets here. 2 more for space, okay? You know what? Like, it's annoying because there's a lot of... so here we go. It's a NAC meeting is what we were talking about. Nope, no more bad news. I refuse. Let me make sure that I got this right. NASA, yeah, okay, so it's a NASA Advisory Council meeting, and it started at 1, into the hearing, mostly reiteration of earlier comments from the GAO and ASAP. Okay, here we go. Starting momentarily is a House Space Subcommittee hearing on NASA's Artemis program. Yeah, okay, here it is. All right, so let's read here real quick. NASA Subcommittee Chair, Artemis is facing serious challenges, delays, cost growth, and a confusing mishmash of contract types. Okay. Subcommittee ranking member, Representative Bailey, we have the correct goal and the right path, but waiting on the right plan. All right. NASA needs to give us an updated plan schedule and a realistic... Here we go. Here we go. Artemis must be NASA's highest priority. Okay. Government Accountability Office's William Russell. Schedule for Artemis 3 net 2025 remains challenging, including a schedule risk for HLS because of 7-month delay starting program. That's from COVID and from the lawsuit from the contract award for the HLS. Let's see. Aerospace Safety Advisory Panel Chair Patricia Sanders reiterates that the panel's past recommendations, including a single manager for Artemis. Yeah, that's actually not a bad idea to have somebody heading up the entire program. NASA Inspector General Paul Martin, we estimate that the first 4 Artemis missions will cost $4.1 billion each, which strikes us as unsustainable. Expect crewed lunar landing to slip at least to 2026. Why don't we have a clear strategy at NASA for Artemis? You need a clear story and understanding. Understand the agency is working on that. Jim Free, this is the guy that runs NASA's Exploration Systems Development. Strategy is putting people on Mars. 2 people on Mars for 30 days. 2 people on Mars for 30 days and back safely. Everything we should do should be driven by that. We saw poor contract performance by Boeing on SLS. The cost plus contracts for SLS Orion worked to the contractor's advantage, not NASA. What about COVID impacts? Okay. We did keep the workforce well connected from a supply chain perspective. It's still to be determined, dealing with issues with tanks and valves. Okay. 30 days on the surface, Swishio. Probably 3 to 6 month transfer window, depending on when they try to do it. Yeah, she's a beast. Bearlicious. Anyway. Representative Perlmutter of Colorado shows off his Mars 2033 bumpers. Okay. One of the last times he'd be able to do it. Did some work looking at potential Mars missions, but no reliable estimates on what a Mars mission would cost. Jim Free announces that Romania signed the Artemis Accords at 10:30 a.m. Eastern. That's good. Should be an Artemis-wide life cycle cost estimate. It's not clear why NASA has failed to agree to such an estimate. Ooh, that stinks, Jaka. Anyway. We support the use of fixed-price contracts so long as they're used with a more firm design to avoid cost modifications down the road. End of the hearing. Mostly a reiteration of earlier comments from the GAO, ASAP, and NASA OAG. Yeah, a couple of you guys posted the link to this in chat. There's a lot there, fellas. You know, I don't feel like going on a rant about this today, guys. Long story short, yeah, of course it's going to cost a lot of money. You're developing the systems right now. When you develop the systems, you're not going to be entirely sure how much someone costs until the system is developed, which is why cost plus contracting exists. I guarantee you that 4.1 billion for the first 4 missions is really, like I said, that's the crawler transporter, that's the launch pad, that's the mobile launcher, that's the VAB electric bill, that's maintaining the VAB, launch control, all at Kennedy Space Center. That's Stennis with the B2 test stand, the A2 test stand for all the rockets being tested. That's Marshall with all its dynamic test stands. That's Michoud, the entire factory. You're carrying the price tag of everything because NASA tells you the full price of it. They tell you total cost involved. It's not like, don't get me wrong, 4.1 billion per is a lot, but that's just for these development missions to be, for the most part, guys. Over time, that's paying for the factory to set up the program. And this is something that I've talked about with scalability a lot of the time. A lot of these missions carry a heavy price tag because you're paying for all the infrastructure to get the program up and running. I mean, so, these comments here, I'll be 100% honest with you. These comments, We estimate that the first 4 missions cost $4.1 billion each, which strikes us as unsustainable. Yeah, because if that was the actual price point per launch, of course it'd be unsustainable, but that's not really how that works. You know, like that's what one of who said that? Paul Martin? What is he? NASA Inspector General. Interesting. Yeah, I mean, of course it's unsustainable, but every space program in history has carried a heavy development cost, and that development cost has always been roped in for the first couple of missions. That's how NASA's been doing this for years. Why would it be any different this time? It might be a late, but just read. Hidden water discovered 3 feet below Mars's Grand Canyon. Valles Marineris Martian Canyon. Oh, that's cool. People also said the same thing with Apollo. Long story short, guys, yeah, I mean, we know the story. We know how this is going to work. Everybody and their mother out there is going to use that $4.1 billion price point and use that as a, write an op-ed article on why you should cancel SLS, etc., etc. You know the drill. You know the drill. I bet you the article's already written and released. So, I mean, yeah, I mean, it is what it is, dudes. I think that the SLS program's going to be fine. One thing that I do agree is that there's really no overall plan. But the important thing to understand is that even with the Apollo program, there was no overarching plan. It's not like Apollo 4, when they launched Apollo 4, was called Apollo 4. Apollo 1 wasn't even called Apollo 1. These were just test flights. And then they named them retroactively because they didn't really have a name for it at the time. So, long story short, the scope of the program really came into focus after they started launching people routinely to the moon. So Apollo 8, Apollo 9, Apollo 10, Apollo 11, 12, 13, 14, 15, 16, 17. That's when the scope of the program really started to come into focus. So, I mean, yeah, the difference here is that Apollo, has Apollo had a deadline. That's the big one. That's first and foremost. Apollo had a deadline, and Apollo also, once Apollo 8 started happening, they started really hitting their stride, and then the program really, really produced some great science. I mean, not to mention people walking on another celestial body. That's pretty cool. I like that. I don't know about you guys. So, yeah, I'm not going to sit here and say that I agree with everything that's said from the NASA Inspector General, etc., etc. But what I do agree with is not having a clear, concise goal, and one person not being in charge of the entire program is probably not a good thing. You're going to get compartmentalization. But the overarching thing, and I've been saying this for years, the overarching thing here is no deadline. No deadline, no accountability in that regard. With rockets, you scale to a deadline, okay? We choose to go to the moon in this decade, right? When you're not scaling the entire program to a deadline, it just creates an insane amount of waste. And in that regard, that $4.1 billion could probably be taken down. Actually, it could even go up if you have deadlines. But the thing is that, this is the part that I agree with. They need an overarching goal, and they need overarching deadlines. Guys, I don't mean to be like, oh, I told you so, I told you so, I told you so. But I mean, look right here. We estimate, and look, expect crewed lunar landing to slip to at least 2026. I'm not going to sit here and pretend like I don't want to be that guy's like, oh, I told you so, you guys suck, everything, I'm always right, because I'm not always right. But I did tell you that rescinding the 2024 landing on the moon goal, rescinding that would pretty much, yeah. We ain't landing on the moon in 2024. We ain't landing on it in 2025. And this meeting does reflect that. That look, you take away the deadlines. You have nothing for the program to scale to. There's nothing for the program to scale to. It's that simple. Once again, though, I'm not gonna diss on the Artemis program. I think Artemis and SLS are good, well-capable vehicles, and I think they need to be there to be redundant to commercial entities. I don't want one corporation being the only. I don't want a corporation being the only way to get to the moon. I don't want SpaceX being the only way to get to it. That's going to create stagnation. That creates a monopoly on going to the moon. And now the government is beholden to a corporation to be able to get to the moon. I don't think that's a good idea. Simultaneously, I don't think that NASA should be the only one that has access to the moon as well. Because, well, that's happened in the past, and what happened? The program got canceled because there was no competition. There was stagnation in the market because we were the only ones that could do it. So I understand that these Artemis missions carry a heavy price tag. I just want the program to be a little bit more structured. If they can get a little bit more structured, and that's, like, once again, that's why I was hype on Jim, and, 2024 we go back to the moon, because that was something to scale to. Deadlines are what keeps this whole thing accountable. You're accountable to a deadline, which is really, really nice. And it's pretty clear that, once they took 2024 crew landing off the table, that everybody laxed their stuff out, and now it's 2026. It was 2025 last year. Now it's 2026. Next year it's probably going to be 2027. It sucks. But once again, you have to get something for them to scramble to. But simultaneously, you don't want to create an unrealistic deadline either. You don't want to be like, oh yeah, we're going to the moon next year. That would get somebody killed. You got to find that they have to be ambitious and they have to be bold. Not Elon time, but something kind of in that direction. No, Focus, nothing yet. I mean, NASA... That's all I'm going to say. I don't really want to go on too big of a rant about that. Let's get to the next news. With that being said, we do have more pictures for the Artemis 3 SLS core. The manufacturing is really starting to come into its own, which is really cool. These are parts of... These are parts of the Artemis 3 liquid oxygen tank right here. Oh, that's pretty cool, Balk. See last for space news. You don't want to rush so the end of the rocket is half-baked. Yeah, straight up. Look at Maternal walking into the gateway module and turn. All right, I'll check that out. So yeah, see, we got some parts here. We got more parts, guys. Every day we see more and more SLS pieces come together. This factory is going to start cranking out these cores faster than you might think. Here, check it out. Look at these pictures. Oh, man. That's really nice. I wonder why they chose isogrid in this area and orthogrid in other areas. Interesting. Artemis 2 is targeting 2024 right now, Sun Temple. Artemis 3 was targeting is still targeting 2025. You guys, the other thing to keep in mind is that, the NASA Inspector General, the Aerospace Safety Advisory Panel, they're always going to give you the worst case scenario. They give you a worst case scenario output because those people are very risk adverse. The idea is that if you have you have NASA that's gung-ho about launching rockets, and you have somebody that's very risk-adverse that's not gung-ho about launching rockets, you can get a better data set, and you can better analyze the risk, which will make you better at risk aversion in the long run, i.e. not get somebody killed. Yeah, you don't want to do that. That would be bad for the program, to say the least, not to mention the person. I'm pretty sure they wouldn't like that. So, yeah, it's just about getting a better data set for risk aversion, guys. So they're always going to tell you the worst case scenario. The problem is that I don't think the press really understands that. They take the Aerospace Safety Advisory Panel as gospel and kind of go from there, which, once again, I don't need to talk about it. You guys know exactly where I stand on that. I think that's dumb. I think that's very short-sighted, and I think, all that's going to do is end up with... all it's going to do is end up with, public reception of a national space program going down, which is probably not good for this space program. Ain't nobody out there going to convince me that less rockets is better for NASA. NASA launching less rockets is better for NASA. I don't think that's right. That doesn't really make a whole lot of sense to me. How do you know it's stir-welded? You can tell it's stir-welded because of the way it is. Also, here, Mike Killian, who's a launch photographer, has a pretty cool shot of the GOES launch if you guys want to see it. I think you guys might appreciate this. This was just linked in chat. Here, take a look. Well, that's pretty neat. Well, that's pretty neat. I don't hate what's going on here. Oh, that's pretty cool. All right. I don't hate what's happening here. Look at that thing. Bro. Are you kidding me? How did you get this shot? Oh, that's an F-86 Sabre, guys. It's a second-generation U.S. jet fighter from the 50s. That's really cool. And there's Atlas. Atlas 541 with Ghost T in the background. This launch just happened a couple seconds ago. Damn, that's cool. Thank you for linking this, fellas. Let's see. Best launch shot. Best launch shot ever. Best launch shot ever. That one's pretty good, man. That's a good one. I like that. I don't hate what's happening there. I'm not gonna lie to you. All right. Let's see. What else do we got? What else do we got? What else do we got? I'm surprised they were allowed to fly that close. They're well outside of the no-fly zone, caveman. They're about 20 miles from the pad in that shot. Yeah. Probably had a friend near him hold the camera. Can you see on the smoke trail where the gravity turn started? It was very quick. 541 has a lot of TWR off the pad, so the grav turn is going to happen sooner rather than later because they have the TWR to be able to compensate for a grav loss. Was the F-86 two-seater? There were trainer F-86s that were two-seater, Winter Scythe, yeah. So speaking of the SLS program, while we're here, Swishio linked this up. Let's see what we got. So this is Luca Parmentano, a European astronaut. Oh, that's Alexander Gerst right there. That's Gerst and Luca walking inside of the gateway modules. Ah, gateway modules. Yep, Talos Linea gateway mock-up. Oh, that's cool. Well, that's pretty neat. Yep, that's Alexander Gerst, a European astronaut from Germany. Ja, ist gut, ja? Aha, wunderbar. Yeah, there we go. These are mock-ups of the gateway modules. That's a VR headset. That's another VR headset. I'm not sure what's going on there. There you go. These gateway modules are being worked on right now. Fake. Clearly there's gravity. Can fit so many astronauts in this thing. Yeah, Swishio, that's not Luca. That's Alexander Gerst. Herr Gerst is checking out the modules. He's very amused by it. Look, you could tell how happy he is from his face. Yeah, that's cool. Note the axial docking ports on the sides of the module, which is actually really neat. See? You have axial berthing mechanisms here along with, or you have radial berthing mechanisms and then an axial docking system, which is cool. That looks like it has a passive IDSS on it, which means like Dragon or Starliner or, well, Orion as well can dock with it too. You mistook one bald guy for the other? Wait, Luca has hair, man. I don't know what you're talking about, dude. It's not a lot of hair, but he has hair like that. Anyway, really cool shots. Those were the mock-ups though, fellas. Those weren't the real ones. Not yet, at least. They are working on them. They're manufacturing them. The Gateway Habitation and Logistics Outpost, so the core module for the Gateway is being worked on right now, with a power and propulsion element, too. Okay, I got that. I don't know, Swishio, maybe. So, we got an update from SpaceX. SpaceX is targeting another Starlink launch on the 3rd, so we got another launch on Thursday, which is pretty sweet. Starlinks are going big, man. Going big. Not space news, but the Galactic Star Cruiser. Oh, neat. We'll use 1060.11 and land on just read the instructions. Fairing recovery to be done by Bob. All right, excellent. Another 11th mission flyer, Thomas. 1060 is the... What is that? The third oldest in the fleet, I think. There's 1058. Actually, I gotta check. Hang on. Here, let's see. List of Falcon 9 first stage boosters. Let's go down here. What's in the active fleet? Man, look at that. Yeah, Mort, I got you. Maggio's on board for the new Futurama series. Well, that's good news. Alright, so the oldest one, 1046, was expended, if I'm remembering right. So... yeah, the oldest one is 1049, I think? Wait, what are the ones with the asterisks? Active boosters that are expected to make additional flights in the future are marked with an asterisk. Okay, so 1049 is the oldest. And this one is on 1060, so that's up here. Damn, dude. That's a lot of missions, man. 1049, 51, 52, 53, 58, 60, 61, 62, 63, 67, 71. Man. Yeah, see this gap right here? Anybody know why there's a gap? 64, 65, and 66? Anybody know? There's a Block 3 still at the Cape. Oh, that's cool. See this list. Falcon Heavy course.
Discovery, go at throttle up.
Yep, that's right. Falcon Heavy for SF-44. Ian, we got some subreddit action here. I actually haven't checked in on this stuff in a long time, dude. Ah, here you go. Here we go. Yep, see? 64, 65, 66 are slated for USSF-44. That's waiting on the payload, guys. When is the next Falcon Heavy launch? USSF-44. It's waiting on the payload, guys. Hey, Chuck. 12-month gift courtesy of Hokey. Thank you. Yeah, man. So how many of these boosters are up? How many of these boosters are up, I don't know, like the, let's see, so that's at 10 missions, that's at 11 missions. They still have some Falcon Heavy side boosters. Oh, no, they converted them, yeah, okay. They don't have any Falcon Heavy cores except for that one, 1064. That one's at the Cape, guys, it's there. USSF-44 is the new fairing? I don't think so. So we have 1060, which will be the third booster to hit 11. That's crazy, man. So what's up at 11? 1051, 1058, and then 1060. Bruh. That's pretty crazy, man. Dude, I can't believe that. And they have way more planned and active missions, which is nuts. 1021. 21 is still there. Retired. Stored at Hangar E at Cape Canaveral until put under permanent display. Cool.
Discovery, go at throttle up.
Oh, yeah. Yeah, I remember. Yep. That's cool. I have an entire booster log to keep track. Yep. I've seen 1019. I watched that booster land, and I've stood next to it, which is pretty rad. That's pretty cool. I thought that was really neat. Yeah, drummer, it's fine. It'll be all right. Octoweb caught fire right after landing. It's retired. Yep. Oh, okay. Interesting. I wonder what happened to that thing. Buzz. There's another core out there. I don't know what it is, but it's really old. Yeah. It's probably 1021, man. That's the other one right there. No, maybe not 1021. It could be 1023. Wait, one of these is heading to KSCVC. Interesting or not? 1050 is the one that landed in the water. Cannibalized for parts to build Starhopper. Yeah, that thing, 1050 is the KSCVC, Kennedy Space Center Visitor Complex. 1023 is going to KSCVC. Yep, so that leaves 1025. Interesting. Cool. Yeah, they got a bunch of spare parts lying around, but the active booster core, man, some of these things got some crazy amounts of missions going on. And it's only going to get crazier, dudes. It's only going to get more nuts. Like, there's so many more planned missions. Unbelievable. 1025 was cut up as gift for employees. Yeah, okay. Yeah. Yeah, you can see the entire lineage of the program. That's really cool. Yeah, this on the SpaceX subreddit, this is great. It had me move out of Hangar M for something to be moved in that hangar. Cool. Yeah, this probably goes down a long way. That's really awesome. It's so cool, dude. There's a fleet of freaking boosters, man. Yeah. Unbelievable. Yep. The Block 5s, 1046 was the first one. The Bangamandu booster, that one's gone. They expended that thing. Crazy. Crazy. All right, so let's see what else is going on. So that's a SpaceX mission that's happening on the 3rd. That's on Thursday. Let's see, what else do we have here? I have some Orbex stuff. Orion has a new program manager because they promoted the previous one. Here. Check this out. I'll read this press release to you guys. NASA has selected Howard Hugh as the Orion program manager based at the agency's Johnson Space Center in Houston. In this role, he will be held responsible for the design, development, production, and operations of the agency's Orion spacecraft, which is poised to make the first uncrewed flight test around the moon in the coming months. Who begins his new position effective Monday. He succeeds Catherine Corner, who has accepted a position as a Deputy Associate Administrator for Exploration Systems Development Mission Directorate at NASA headquarters in Washington. Basically, they split up the NASA programs last year between like people that are working on like rocket R&D and operational missions, and this is part of that split thing that's going on here. That's pretty cool. Sweet. Yeah, so that's pretty cool that they got a new manager there. All right, so Centaur is still coasting. The next burn for the GOES-T mission, which is still going on right now, is in about 2:20 right now. So let's see. I'm gonna put that news there. Yeah, Howard Hughes, back from the dead. All right, so I got a little bit more news around here, but people have been wondering about what's going on with the ISS. Honestly, guys, nothing. NASA has said that they want to keep going with the ISS project, and obviously Roscosmos is on board with it as well. So, believe it or not, ISS operations seem to be, at this point in time, as of March 1st, 2022, ISS operations seem to be wholly intact. I mean, there's going to be a Soyuz coming down with Anton Shkaplerov, Peter Dubrov, and Mark Van High very soon. And they're going to land in Baikonur, and they're just kind of going to keep going business as normal. Hey, Del, what's going on? If Russian space program could go where Russian ship is. Damn it, man. Yeah, no, it kind of blows, dude. It sucks. But, yeah, I mean, Dmitry is not It's not happy about this, I don't think. But it seems to be business as normal for now. Now, whether sanctions or something is going to mess with that, I don't know. But it seems to be normal operation for now. It's for the best of the world. Yeah, dude, it sucks, man. It sucks that it has to be this way. But I was really gunning for them to, you know, especially the Russian program, dude. I wanted them to, you know, screw working with China. Work with us, man. Let's go to the moon. We don't have time for this bull crap on the ground, dude. Am I right or am I right? But anyway, I still have to cover the guy's tweets. I want to know what's going on, Kim. Same as usual, and I don't like doing it, but we have to. So let's figure it out. Let's see. He tweeted this today. What's going on? You know, I used to stand on that too. Yeah, it freaking sucks, man. It sucks, dude, because, you know, like I said, man, you know, I know that there's guys that work for Roscosmos that are probably like, oh, great, you know, great. This is great. Yeah, this is really gonna help us go further in space. Am I right, guys? You know, it's not like Rogozin has a choice in the matter anyway, even if we wanted to. Yeah. I'm sad that ExoMars will probably get mothballed. Yep. Yeah, ExoMars is out. Roscosmos pulled their technical expertise from the Soyuz launch pad in Kourou because of EU sanctions. And let's see, what's going on here? This is kind of interesting. Let's see. Okay. Interesting. In the context of the announced sanctions, Roscosmos will reconsider its priorities and focus on achieving full import independence in the matters of space instrumentation. The main design, technological, and financial resources released from joint ventures with the US and the EU. It's interesting that he showed a Proton rocket with a... Is that a BTR? Okay. What, are you going to keep Proton rolling or what? Yeah, exactly, Kem. It's kind of a dick move. I still think he's stuck between a rock and a hard place, though, man. Really, he knows, dude. Dmitry knows good and well what would happen if they, you know, did what they did, and I think that's weighing on him a little bit. But I think that his allegiances to said constituents is overwhelming his judgment. But that's just a personal note. I could be wrong. You know, small PP move, indeed. So at least the ISS is going to stay intact for the time being, guys, which is, you know, that's okay, you know, because it's not, I mean, that brings me to another thing, dude. It's not, you know, remember, look, when the U.S. invaded Iraq, I wasn't okay with that. When we invaded Afghanistan, I wasn't okay with that. You know, I wasn't okay with that. I did not like that. You know what I mean? So the point that I'm trying to get at is that, you know, pretty sure the vast majority of Russians over there are not on board with this. They're totally not, like, they're not good with it. So just remember that, dudes. It's not, you know, just because it's a government, like, you know, how much does the government speak for you over here? You know what I mean? Like, just remember that, dudes. Now, I'm not saying Dmitry gets a pass or anything. No, he's doing some small PP stuff. You know what I mean? Yeah, Jim. I mean, that happens with people over here all the time. You know? But yeah, just remember that, guys. You know, it's not fair to, you know, I know there are plenty of folks in Russia that are not good with this. You know what I mean? You have that thing called yeah, that's true. That's true, Kim. We do. I like that a lot. That's why I like this country so freaking much. I like the U.S., man, because it prevents stupid stuff like this from happening. I mean, but then again, we've made mistakes in the past. Nobody's perfect, you know? A bit more detailed part of this tweet. All right, let's see what we got. I still think that Dmitry cares about the space program, but I think he's letting his patriotism cloud his judgment, you know? Like, and that's something I don't think is going to be good in the long term for Roscosmos, you know? But who knows? All right, fellas, we're not talking about systems of government for different things. So do me a favor and of that topic. Let's see what Katya's up to. Dmitry Rogozin plans to reconsider Roscosmos' priorities and focus on achieving full import independence. He also stated that all of the resources released from joint international research projects will be directed to the creation of defense and dual-use space systems. So yeah, they're trying to homologate their space program because no one's going to work with them. Which, yeah, I get. It kind of sucks, man. It kind of sucks that it has to be this way. But, hey, rule 8 gonna rule 8, brothers, am I right? Hey, fellas, look, don't get at each other's throats. Come on, man. Don't we get enough of that? We're all here for space, and remember that. We can disagree about stuff. But we're all here for space, and we all agree on that. Am I right? So, once again, I don't want to be covering this kind of stuff. I really don't like it. I really don't like war. I really don't. It's really not a good idea. And as an American, I'm saying that, like, probably shouldn't do that. Probably shouldn't. We know good and well how this is going to. And you should shut the fuck up. Anyway, moving on. So I got some good news. Coming out of this. There is some good stuff. So everybody assumed that the AN-225 was gone. But there were satellite images from yesterday. Here, take a look. I'll let you guys check it out. Look. Uh-oh. Let's not give them attention. Yeah. But also, Kem, hell yeah. So, I have a theory about this, and don't get me wrong, there's a lot of propaganda being thrown around by all sides everywhere about this 24/7 all the freaking time, right? And then there's a lot of misinformation out there. There's a lot of unconfirmed sources. But I have a theory about this, and something I do know pretty well is about kinetic energy and experiments and how this all works. Now, check this out. This footage, or the satellite picture, shows the tail of the Dream. It's still there. Now, okay. Does that mean the plane is in one piece? Hell no. No. That doesn't necessarily mean it's intact. But do consider this. Okay? The scuff marks are right here. There's no scuff marks right here. Now, what does that mean? What do I think happened here? I think the Ukrainians were trying to get this thing out of there. I think they were trying to get it out. And I think they brought a fuel truck over to try and fuel the plane up to get it out of Hostomel Airport, and that's what got hit. We know from the footage of it on fire that it was a fuel truck because it's burning really, really dark. Anytime you see flames that are burning really dark and the clouds are really dark means it's very fuel rich. It's a very fuel rich flame. And you're getting unburnt hydrocarbons, kind of like a rocket engine. Kind of the same thing that happens with Falcon 9. Same idea. So I think that a missile came in here. It came from the north, which is this way. North's down there. South is that way, right? Which is where the Russian forces are coming from, right? I think it came from the north, and I think they hit a fuel truck here. Now, you could tell because of the way this kind of propagates out this way. There's a lot of dirt and garbage stuff getting thrown in this direction, south, which is the way a missile would have came. Now, how does that explain the damage to this hangar? Well, the damage to the hangar could be... My guess is that this fire is probably burning extremely hot, and if the wind was blowing east-west, which it does, if the wind was blowing east-west, then that fire, the heat from the fire would have started melting parts of the hangar, which is why it fell apart. I think that's what's going on, which means at worst case, the AN-225 has some really, 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 really scorched paint. But I think, dude, I think that thing is still in one piece. That's just my kind of analysis of the situation. No, I'm not an official source, but I also really like huffing that copium, man. That copium. I'm gonna hope. Give me the hope. Give me the hope, man. Give me the hopes. Give me the hopes. It could still be in one piece. It could still be in one piece, dudes. I hope it is. I really hope so. That'd be a real loss losing that thing. You know? Yeah, stealth, but hey, you know what? If the airframe is intact, man, wires are replaceable. If the airframe is not replaceable, then we got a problem. Now, okay, so let's think about how badly the vehicle is damaged. What are the parts on a 225 that you cannot replace? the wings, the tail, and parts of the fuselage. Why? Well, I wanted to kind of do a quick little rundown about what the 225 actually is. So the AN-225, which is the reason why I even give a frick about this plane, is because it's the largest plane around. It's the biggest plane flying today. Well, it was. If it's broken, it was. But was, asterisk that statement. So what is it? Where did it come from? So the 225 is an extended fuselage version of this plane. This is an Antonov 124-100. That was the Soviet Union's heavy cargo plane. These planes were designed to move tanks around and stuff. It would be something analogous to a C-5, a Lockheed C-5. Basically the same idea. They even look kind of similar. They're not copies, but they look kind of similar. Yeah, Demon, that's old news. That's old news. Irrelevant. Old news. These shots were from a day later than those. So, yeah, I disregarded that. So, now, why would they stretch a 225? To move more tanks around? Why would they stretch a 124? They fit more tanks in it? I mean, it can do that, but that's not why it was made. The AN-225 was made, and this is where it ties in, and this is part of the reason why I care. The 225 was made to do this. It was made to carry around the Buran. That's what it was designed to do. That's why that plane is cool, because it's carried a space shuttle around. Multiple times. Okay? That's why I'm so concerned about this dang plane, and why I want to believe that it's still going. You know? I want to believe that this plane still exists because it's that, you know? So, with that being said, a couple of things that you can notice, all right? So what happened after? So this was made by the Soviets. This was made by the Antonov Design Bureau during the Soviet era. When the Soviet Union collapsed and Ukraine became a separate country. I don't want to hear your hot takes about Ukraine right now. Shut up. Just listen. When it became a separate country, Antonov became a privatized corporation, and they used this for heavy cargo moving. It's been moving around heavy cargo ever since. But it was designed to move space shuttles, which is really cool. I don't give a frick if it's a Russian space shuttle. That's still a space shuttle. It's a beautiful frickin' plane. It's just very nice looking. It's a very aesthetic plane. It's very pretty. It's got 6 engines, man. It's the biggest plane flying around today. Or, well, either was or were flying around today. I don't know. You guess. So, could it carry the American one, though? I don't think they have the same attachment points, T-Man, but yes, it could. How far? I don't know. It's a beautiful, 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 beautiful plane. So that's why I'm kind of hoping that the thing is still in one piece. Now, how can I tell? Well, once again, there was footage, we had some satellite pictures of the hangar ablaze like this, but I mean, in this shot, it looks like the plane is very, very much on fire. But I'm telling you, the focal length of this picture screws this up. It looks like the plane's on fire in this picture, but it's not. I'm telling you, it's not. I really don't think that it is. Now, why? Why would I think that? Well, if you look at other satellite pictures, the scorch marks are all in front of the dang plane. If you look right here into the hangar, the concrete is still relatively intact. So I think the focal length from that picture was screwing it up. Now, if you go back and look at this one other image, there's another thing to kind of tell. You could tell that there's light being shined underneath the tail of the aircraft. Now, what does that mean? Why light being shined under the tail? Who cares? Well, the thing's destroyed. Hold on a second. When planes catch on fire, and they do, if they do catch on fire, there's usually not a whole lot of plane left. But how the tail ends up sitting on the ground usually is a pretty good telltale sign of the status of the airplane. But if you've noticed, planes that catch on fire and like burn to the ground, like total loss, burn to the ground, the tail is usually intact. Now, why is that? Well, if the center of the plane catches on fire, the wing box melts because planes are made out of aluminum, and aluminum is not very good at absorbing heat. We know that because of the space shuttle. So usually the aluminum or almonds, that stuff usually melts, and the tail usually just falls off because all the aluminum melts because the plane is on fire, and before the fire can get at it, it melts all the aluminum, and the tail falls because the aluminum frame is what's holding it up. So, that tells me that the wing box of this plane is still intact. I don't know what's going on with the front. I don't want to know. Well, I do want to know. I really want somebody to just kind of snap a picture right here, like looking this way. But the tail being up in the air means that the airframe of that plane is sitting on its landing gear, which means it didn't catch on fire. At least a lot. Allman Brothers? Yes. Yeah. Which means the plane didn't catch on fire. And it didn't burn totally to the ground. That's what that means. If that tail is sitting up in the air, that means that plane's on its landing gear, which means the wing box didn't melt. And if the wing box didn't melt, that means the plane is still standing in some discernible condition. Anybody here that's ever looked at pictures of a plane crash? Now, I'm not showing you pictures of a plane crash because there's usually some charred smoking biological things inside of a plane crash that I'm not going to show you on stream. That's not very appropriate. Now, if you ever looked at it, there's usually not many discernible pieces of the plane left. The fact that the tail is A, up in the air, and B, still standing, tells me that the airframe is fine. Well, relatively fine. The plane's sitting on its landing gear still, which is a good sign. That's a good sign, man. And that coupled with this overlay that Paul Byrne did this overlay. He's a planetary scientist. He did this overlay. That shows that the paint might be a little bit scorched from the wind blowing those hot flames towards it, but I think the plane's okay. I really do. I mean, if you look at a picture of the 225, if that tail is still, that tail would snap off if this thing caught on fire. So I think the front might be a little bit scorched, but that plane's main landing gear is still intact. Guaranteed. The tail would not be standing if it wasn't. Yeah, maybe Cerebral, maybe. Use a pic from one of the crash tests. Actually, that's not a bad idea. Here, hold on. How about we'll use the NASA 707. NASA 707 crash test. The front could be burnt up a little bit, but that's replaceable. The other thing you got to remember, this is an extended Antonov 124. So if the wing box is intact, you could just graft another Antonov 124 onto the front of this thing, fellas. It's made out of 124 parts, so there's no shortage of parts. They also have another airframe that they could section off, and you could make one good one with it. There's two AN 225s. Just one of them is half complete. So that's a really important thing to understand. I think the evidence is in favor of this plane being relatively intact. At worst, or at the very least, the paint's burned. At the very worst, the front fell off. But, once again, if the front fell off, the center of mass would go behind the main landing gear and that tail would hit the ground. Am I right? Am I right? That's just plane physics. That's not speculation. That's just how planes work. Right? If the front of that plane snapped off or caught on fire or was destroyed, the plane would be pitched up on the ground and that tail would be into the ground. Tail isn't into the ground, dudes. Seeing the tail like that showed me everything that I needed to see. Well, the front fell off. Yeah, the front fell off. Yeah, here, let's show the NASA test here. Anyway, why can't you build a new one from zero? I'm sure you could, Rev. Of course they could. Watch. See? Dark smoke. When you see dark smoke like that, that's unburnt fuel. So, Reveril, what I think happened is that the Russians took out the fuel truck because they didn't want the 225 to escape. I think they took out the fuel trucks, and I think the fuel trucks burned to the ground, and that may have scorched the paint on the plane and damaged the hangar a little bit. But that plane's still standing on its landing gear. I know that for a fact. Physics says that that's true.
The Eagle has landed.
Copium dealer! Or I'm just hitting the copium too hard, man. Just could be hitting the copium too hard, man. That could be true. But until I see a picture of the plane burnt to the ground, I'm gonna keep hoping, okay? Bruh, I just gave you a month's worth on Saturday. I'm sorry. It's in one piece for now. That's right, Ark.
Discovery, go at throttle up.
What was the test they did to confirm some of the Sioux City stuff? I'm not sure. Gotta go get that copium, bros. That's right. Can you confirm this just came in? Having you... I don't know, Raw Style. That's out of my purview, brother. Leroy, I'm looking for your last, dude. Let's see. Yeah, see, this is what happens, and that's a similar cloud to what we saw. I think it hit the fuel truck. I think they were hitting the fuel truck. I think they know not to hit the plane because of the propaganda victory there. If you're talking about Kiev, go check the Antonov Museum in the Kiev airport. You can see Street View, and there's some cool stuff. Oh, neat, Leroy. I didn't know that. Ian, what are you saying? The Rocket Guy said earlier, and I agree, we're looking into the hangar at an angle, so it probably stretches further forward than the hangar. Yeah, Ian, but once again, if the front was damaged, that the tail would be on the ground. It would be. There's no getting around that, dude. The tail is it's still up in the air. So, dude, I honestly think she's still intact. I think the focal length from this picture screws everything up. So, at the very worst, because look, see all the dark smoke? See what I'm talking about? That's the fuel truck, man. They hit the fuel truck. The Russians wouldn't want to damage that plane. Why? Why would they do that? See what I'm saying? I think they didn't want anybody to escape, so I think they nailed that truck. They nailed it with a cruise missile and freaking hit pretty straight on. I think that's the shadows side of light smoke. It could be, but the scorch marks on the ground in this picture predominant indicate that something really hot burned right here. So, once again, the fact that... Oh, don't show me that. Yeah, see? Yeah, when planes burn to the ground, that's what happens. The tail falls off before the plane catches... Oh, I can't watch this. Oh, I can't watch that. I can't do it. 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 I watched that Nova as a kid and was traumatized from it. Oh... So it does not look like the plane is fully on the ground. Rev, that's what I'm saying, dude. I think it's fine. I think the plane, well, I don't think it's fine. It's probably broken in some way, shape, or form. A fuel truck did explode right next to the plane. Even if the plane looks intact, I still would probably take it apart to be sure. Any A&P knows that flames near the outside of the plane is probably not something you want, you know? So, once again, that tail, you could see light being cast underneath it. That tail is still up in the air, which means the plane's still sitting on its landing gear. And that means that the wing box is intact. So it might not be as destroyed as previously anticipated. You know? And I get it, the satellite picture, Rocket Guy, you're right. It'll stretch a little bit. So, I mean, point still stands. If the tail was down on the ground and if it was to the side and kind of twisted over, then I'd be like, yep, that plane's toast. But it's not. It's perfectly square inside of the hangar, and it's pointed in the right direction, and it's not on the ground. You can see light being cast underneath it. So I think we're good, man. Yeah, they clearly missed some of the fuel trucks right here. You know, I'm gonna keep hoping. But actually, guys, if this plane is relatively intact, there's two things that I'm kind of like, about. One, what's that? Why is that there? There's a hole in the roof. That's not good. That whatever came through that, yeah. Hopefully that's just a piece of debris that came through there. Or like a casing from this cruise missile or whatever. Second part is, the hangar was clearly damaged from the fire here. And I hate saying this. I hate saying this out loud. It's going to hurt to say. I hope that the structural integrity of that hangar is okay. Because if it's damaged and the structural integrity is compromised, it could collapse. Antonov has not said it's been destroyed. Currently, the AN-225 has been inspected by experts. We cannot report on the technical condition of the aircraft. Stay tuned for the further announcements. Gotta call Integrity Farms. Yeah, I think that the hangar... I'd be more worried about the hangar than the plane at this point, because if the hangar collapses, man, I mean, it would be poetic, but... Now, why would it be poetic? Let me clue you in on a little bit of spaceflight history. The orbiter, the space shuttle that plane was designed to move around, got destroyed in a hangar collapse in Baikonur. Buran's fate, exactly. The Buran orbiter, the only shuttle that the Soviet Union ever launched and made it into space and came back on its own, on autopilot, nobody aboard. was destroyed in a hangar collapse in 2002. So, please, we better pray that hangar hodls. Hodl. Diamond hands on the hangar, bros. No, there's still a Buran sitting around, Ivan. There's the second one. Never flew into space, but the second one is still alive. Burya is what it's called, the little bird. It's sitting in Baikonur in another building, and that building's structural integrity is going down the tubes too. Dmitry has tried to procure it. Maybe he'll just do it by force, because it seems to be that kind of his boss's MO. Who knows? But yeah, I'd be more worried about the hangar than anything. I'm pretty sure that plane is not... That plane's pretty much intact, to the point of it being recognizable. Because the thing about planes that catch on fire is that once they catch on fire, all you can recognize is the tail. You're not going to find anything else. So, I think she's okay. A little bit of good news coming out of this. I think that plane is fine. But once again, I can't prove it. Not yet. But either way, it's a triumph of freaking engineering. I mean, this plane is... She's a beast, man. She's an absolute beast. They had individual names for the shuttles. Yeah, Buran, which is the Russian word for blizzard or snowstorm. And then Mirya is dream. Yeah, she's a beast, dude. Let's hope that she's okay. We already lost Buran. That's the one that got destroyed in the collapse, which really sucks. This picture is after that thing flew into space too. This is Le Bourget in 1989. That thing has flown to space in this picture. There is another chassis around, and once again, the AN-124 and the AN-225 share a lot of common parts, because the 225 is a stretched 124. It's a stretched version with 6 engines to be able to carry around the shuttle. So, even if it is a little bit damaged, guys, it's not even about replacing the airframe. They can graft a 124's nose onto it. It's the same piece. From about here forward is exactly the same. So they can graft another nose onto it. I'm not worried. The wing box is what I'm worried about. The wing box is the part that's not really replaceable, and even then, there is a second AN-225 airframe lying around. So you can fix it. What I'm trying to tell you is that even if the plane is partially damaged, it's fixable. It's definitely fixable. They could fix it. They could cut this. They could cut the part of this thing off, cut parts that thing out, and make one good one. So yeah, I think she's alive. I think that plane is good. To be honest, the tail wouldn't be up in the air if it wasn't. Just saying. Just putting it out there. And the second 225, of course, I chose the potato image. This is the hangar that's across from the first one. There's a hangar. You can see the shadow of it right there. That's inside of this hangar.
Go at throttle up.
Hey, Zeon, 16-month resub. Voss News. What's that? Oh, that's cool. Neat. Since it's such a great plane, why did they only make one? Well, the Soviet Union collapsed before they could finish the second one.
Discovery,
but
go at
yeah,
throttle up.
the Soviet Union collapsed before they could finish the second one, and it was only designed to move the shuttle around. But see, the wing box. That's the part that's irreplaceable right there. See that? Well, not irreplaceable, but this and this. The rest of this is just Antonov 124 parts. The landing gear is swappable, the engines are swappable, the control systems are swappable. I ain't worried about any of that. Hey, Juicy. Welcome to Mission Control. You go with throttle up. See? How good is the ground effect of that plane above water? I mean, I don't know, dude. I would guess with that much wing real estate, it's probably pretty freaking good, man. I don't think it's any Caspian Sea monster, Reveril, right? But I don't think, like I said, I don't think it's a sea monster. But I'll bet you that ground effect is immense. When it doesn't matter if it's near water or a runway. From a structural point of view, it's probably better to part out the original to finish the second. Yeah, if you have to. Yeah, just swap all the parts over because the aluminum airframe. aluminum doobie like that. But yeah, either way, guys, if the plane's partially damaged, if it's just got a little bit of scorched paint, I think that plane is still in one piece, relatively in one piece, to the point where it's probably recognizable. I don't think the plane needs to be reshelled, I guess. But, yeah. As long as the wings and the tail are okay, and they seem to be all right, who knows? But then again, I just could be hoping a lot. Who knows? But also, AN-225, man. She's a beast of an airplane. Kind of want to build one in KSP. Kind of want to. I heard the bigger plane, the bigger the ground effect. Yeah, man. The more air that wing moves, the bigger the ground effect. Absolutely. I heard it was totaled, so bearing in mind that money was no object, what would you change? Nothing. The AN-225 is a... Dude, Rocket Guy, tell them how difficult it is to make a plane like that. You don't know how strong the wing actually has to be to hold something like that together. 6 engines out on the wings. And you remember, making wings is difficult on an airplane. Why? Why is it difficult? Just build a freaking piece of metal that goes out. No. Wings on planes need to bend. They need to have a little bit of bend. But how do you put engines on there and make it so the wings don't fall into the ground, but also make it enough to bend? I mean, that's just, I'm cherry picking one thing when it comes to the engineering, but it's tough, dude. It's tough. That's hard to do. This is why we don't have planes that are the size of aircraft carriers flying around, because you're running into structural problems when you make a plane bigger. It's similar to how rockets don't scale very well. Sea Dragon notwithstanding. But yeah, this is a triumph of engineering. Like, it's not just stretch the plane, give it bigger wings, and call it a day. It's not like Kerbal. There's a lot of extra dynamics going on here with making a plane just a little bit bigger and making the wings a little bit bigger and giving it 6 engines. It's a little more complicated than that. I mean, the fact that the thing even flies is just damn impressive. There has to be something that could be improved. All right, we want to play that game? Give it... You want to play that game? Give it 6 GE9Xs. We'll give it 777 motors. It can handle it. Probably not. Do you see what Anon is claiming right now? No. Give it 6 GE90s, but even giving it 6 GE90s, you'd probably break the wing. Rip mirror. Nah, Checkered, I don't think so. I think that's bullcrap, dude. She's still in one piece. Just throw some MCAS on it. Well, we don't want it to crash, Pipe. To be honest, wings are a lot less of a problem now than 20. Oh, yeah, okay, Tessa, yeah. Let's just go and re-engineer the wings on the plane. We got better technology now, right? That'd be easy to do. Making it strong is easy. Making it strong enough is the hard part. Yep. 3D printer, let's just 3D print it. I mean, you could. That'd be kind of neat. But yeah, I hope the original one is intact, man, because of the continuity. Just add bigger engines and call it the 225 Max. Boeing never had problems doing... Yeah, predominant at some points. Design just has, an airplane wing box just has a theoretical limit. And I think we found it. Did you ever record the LOX tank pictures? Yeah, Novus, I did it right after we talked about SLS and stuff. Novus, I had a question. Why isogrid, octogrid welded to each other? What's the point? I mean, it's obviously because of load and how the load is dispersed through the LOX tank, but yeah, that's really interesting. I noticed that the LOX tank had a mix. It had isogrid and orthogrid right next to each other. Very interesting. Anyway, So that's all I'm going to talk about with that. Let's see what else we got. So Orbex, European space launch company here, is tweeting out some new stuff. So this is from a week ago. Wow, I really wish they didn't boost the audio like that, but I had the audio boost left over from the NASA stream because boosting NASA's audio makes it audible. Boosting everybody else's audio that knows how to mix it correctly, that blows your eardrums out. Here, let me mute the stream and make sure that this doesn't blow my eardrums out. There we go. It's at an audible level. Also, I think I just probably ticked a couple years off my hearing because of that. Yeah, there you go, Vaxsock. That's right. Oh, that killed chat. My bad. Guys, I admit it's a great plan. I'm just saying it's gone, and if it needs to rebuild, what's the harm in incorporating what we haven't learned in the last 30 years to make it better? Yeah, Badger. Hell yeah. Dude, let's get that thing going. Let's stretch that plane to its design limits. That would be pretty neat. What? Is to reduce resonant vibrations, T9? Yeah, all right. Cool. I mean, it's possible. I just noticed that. Yeah. Mop. All right, here we go. Ready? Test stand parts. Yeah, it looks like parts to a test stand or a launch pad. It could be either one. It looks cold and rainy and clammy. Where are we? Oh, yeah, that's right. I know, PY. It's very strange, isn't it? Okay, what are we working on here? All the guys in the shot are mostly called Dave, Steve, or Dan. What about Bulb? Oh yeah, building out a test stand here. Oh, sun came out for a second. Nope, never mind, back to clouds. Oh, sun came out for another. Nope, more clouds. The sun's out for an extraordinarily long period of time. Cool. Last boss, no joke. You recognize some of the roads. Interesting. Is that a test stand or a launch platform? Our launch platform, built by Motive Offshore, made an 80-mile road trip from Peterhead to Kinloss earlier this month. Loaded in the back of 2 huge trucks, it traveled through sun, rain, and snow on its 3-hour journey. And we were on the ground in the air to... Oh, that's the launch pad. Ooh, ooh, ooh. The bottom part is pieces to this. Ah, that ain't a test stand, man. That's the launch pad. Oh, even better. Mint. At least I don't have to dig out my house every 10 feet of snow every winter. Hey, it's 3, okay? It's 3, and also, shut up. All right, what's the second? Ah, yeah, here we go. There it is, man. Cool. Launch site in the UK. You ever thought you'd see the day, fellas? Like, I never thought we'd see that. That's crazy, man. Freaking launch pad. When did this happen? So, RAF Kinloss. Where are we in the world here? Very bing chilling. Bing chilling. Oh, bing chilling. RAF Kinloss. All right, where are these pads, Thomas? I don't like all the X's that are here. Hey, it's Starbase, okay? Actually, it looks like it's one of these guys here. Scottish Space Program, indeed. Right, mate. Yeah, we're going to go and we're going to launch everything up into space, mate. It's going to be right. It's going to be quite nice. Oh, man. This is a nice big airfield, man. We should use this. Ooh, what do we got over here? Hello. Hello. Hey. 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 Please tell me we got street view up here so we can go and look at it. Yeah, I know what that is. Oh yeah. Cool. It's a Nimrod, man. Oh, that's mint. They're building it right now, Reverell. Commercial Space Center in Scotland for polar launches, dude. You're a Nimrod. No. I can't... Nimrods are cool. But are they, though? I can't decide. Is that a cool looking plane or not? I can't tell. I'm not like... I mean, yeah, it is, but it's also a little weird looking. But it also looks really cool. But it also is very weird looking. I love the wings, though. I think the engines and the wings in the engines look amazing. The tail looks a little weird. And it's the nose. I can't tell if the nose looks cool or not. Like, yeah, that kind of looks cool. But it kind of doesn't either. See that? That does not look cool. No. No. That's not, nope. I like that. I don't like the other one. So this is, guys, what you're looking at is a maritime patrol craft. This has a bunch of downward facing radars and stuff. That's why it looks so weird. It's a comet. If it's a de Havilland comet, that's what the plane's supposed to look like. Oh, comet. Oh yeah. Oh yes. 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 Yeah. That's nice. The only thing I don't like about comets is the tail. The tail looks like a B-17, and therefore it looks ridiculous. Everything else about this plane is just... If we just took the Nimrod's tail and we put it on the comet, it's like, see, that has a cool looking tail. I like the Nimrod's tail. If we took the Nimrod's tail and we just put that on a comet, that would be very nice. Ugh. Not the part about them rutting? Yeah, make sure we give it circle windows and we'll be good. Dude, I can't tell it. I like the silhouette of the plane, but it looks ridiculous. But it also doesn't. But it's weird. That's a weird looking plane, man. The spy plane variant is weird. Yeah, yep. So, what do you expect? First jet airliner. Yeah. Looks like it came from Fallout. Yeah, kind of. I'm wondering where Orbex is going to launch from. I would guess that it's probably one of these pads over here. I don't know what these are for. I think these are helicopter pads or something. Or they could be ICBM bases or IRBM bases. The launch mount was constructed in that video, was installed at their testing site, which is at Kinloss. The actual area will be in Sutherland. Oh, it's a test site. Oh, okay. Sutherland. Why don't they just launch out of Kinloss? Right? Just launch that way. Oh, that's why. That's why. There's stuff in the way. Not a lot of stuff. This is where the spaceport will be. Yeah, that's what I thought. There's enough stuff in the way. Yeah, okay. Neat. Yeah, there really isn't a lot of anything up there. How... Okay, let me go into Street View. How remote are we talking about here? Oh. Yeah. Okay. There's a whole lot of nothing.
Discovery, go at throttle.
Yep. Yeah, entropy. Yep. Yep. A whole lot of nothing. Great for a launch site. Cool.
Discovery,
Yeah,
go
that's
at throttle.
way up there. Oh, yeah, that's... Yeah, okay. Yeah, there's a little ways. How far are we from Glasgow right now? Okay. Okay, yeah, we're a good ways up. I mean, it's not Scapa Flow, but it's way up. It's close. Yeah, that's a long way. How far are we from London here? You could say that some people will walk 500 miles for this launch. What? I would walk 500 more. I guess miles. What? Get out! Get out! What? Maybe that's what they were talking about. What? My soul, it hurts. My soul, it hurts. How do I gift negative subs? No, they were proclaiming it, not talking. Why don't they just take the bus? Why would you want to walk? That's just take the bus. The first launch better be called 500 miles. Oh gosh. Well, yeah, no. I mean, they'll go into a 500-kilometer orbit. I mean, sun synchronous out of there. Now, let me just take a look. Can we? I think the launch corridor is only to the north because there ain't much up there. They'd most likely launch sun synchronous, so orbit's going in this direction, right? Now, let me just take a look. Let's see. Yeah. That's about as far as you can go that way. Actually, hold on. Let me switch this to kilometers. I'll be able to tell better. 600 kilometers is usually about the ballistic trajectory for a booster. So let me take a look. Yeah. They're not going to launch over the Baltics. Not the Baltic Strait. They're not going to launch this way. I don't think Norway would be too happy about it. Well, they launch stuff into space too. Yeah, it looks to be polar orbit launch corridors. Polar orbit launch only. But yeah, pretty cool. Neat. All right. Let's see. What else do we have? I do have the Starship stuff. Let's see what's going on over there. I want to ask something, but it could slide into political stuff. Why are people proposing how the ISS can be boosted with only Dragon capsules? Contingency plans, dude. Contingency. Right now, NASA has no plans for not continuing working with Roscosmos, believe it or not. Yeah. So the ISS is going to kind of keep going the same way it's going. It was just people theory crafting, Ivan. Now, what does that mean? Just thinking about what we could do in the event that we just decide to detach the Russian modules. But I don't think that's going to happen. Russia forfeited their bro card. That is putting it nicely. Yeah, that's putting it very nicely. Yeah. I would call that something different, but you know, we got to keep it classy. We got to keep it classy. Starship videos. All right, so this footage is coming from Nick and Sweeney over at NASA Spaceflight. Make sure you go over there and give those guys a sub, because they give us this crisp, clean, high-quality Starship update footage every day. Because we can. Ivan, one thing I should add before we get into the Starship stuff. NASA has contingency plans. You wonder why NASA takes so freaking long for every freaking thing that they do, right? It's because they have contingency plans. Guess what? NASA already had plans. They already made plans when the ISS was being made. Contingency plans, in case something happened, an international incident happened, like now, to be able to save the ISS if international cooperation gets abandoned. They thought about this when they built the dang thing. That retires risk. It retires risk. There's contingency plans all over the place to be able to save the ISS if one international partner decides to pull out of that project. NASA made the plans for it. Long time ago. Actually, 20 years ago, dude. That's why they take so long. Because they think about stuff like this. They're doing contingency plans with this with SLS right now. Guaranteed. Part of the reason why it takes so long. With Gateway, SLS, you think about everything. You try to think about everything that could possibly affect the vehicle, analyze it, and add that to your data set. It's how they retire risk, man. Basically, you don't want to spend a couple $1 billion on a space station and then have that $1 billion quite literally burn up in the atmosphere. You know, if one partner decides, frick you, I don't want to do this anymore. See what I'm saying? Once again, that's part of the reason why NASA takes their sweet freaking time, so they can set the benchmark for how spaceflight safety should be. Now, once again, you know, do I think commercial could do it better? Yeah, probably. But commercial should probably have a benchmark for this. You know what I mean? How do they decide what parts of the station go to who in the event of a split? Joke. The Zarya is owned by the United States. Serious. Zarya is ours, believe it or not. We own a Russian module. So, yeah, I don't know what's going to happen there. No, Ivan, nothing's happened yet. Business as normal for the time being. Yoshi, hey, what do you think about the C-17 Globemaster 3? It's a good plane. McDonnell Douglas plane. Yeah, they're good. I like C-17s. Nice plane. Replaced the C-141. I think I don't know how many of those were made. I think like 80 or 90 of them were made. And then the C-17 factory in Long Beach, Relativity Space bought it. That's right. A rocket factory bought the C-17's factory, which is actually pretty cool. All right, anyway, let's get back into the Starship footage, dudes. Nah, the C-130, they're still making them, Surfer. Believe it or not, they still make C-130s. They've been making C-130s for almost, not a century. They've been making them for 60 years. Yeah, and there's no signs of them stopping. That's how good of a design that was. Thoughts on the B-52? Yeah. There's a reason why most of the B-52, no, all of the B-52s flying are older than the people that are flying them, because it's a really damn good design. They really broke the mold when they made that plane. The B-52, the C-130, guys, those are amazing designs. Amazing. Okay, so what's the reason why? What's the reason why these designs have lasted so long? Well, the C-130 is designed to basically have the trash beaten out of it. It is designed to land on dirt. It is designed to land on gravel. It's designed to land on snow. It's basically an SUV and a plane kind of rolled into one vehicle. They can land. They can do short takeoff and landings. They could do, they have JATO assist. They can. The gunships, everybody likes the gunships, the AC-130s. You can do anything with it. And the reason why is because the airframe is way over-engineered, because the plane was designed to be landing on anything. It can land on what's called unprepared surfaces. And that's part of the reason why it still has propellers, because landing on an unprepared surface with a jet engine is bad, because if something gets into the jet engine, you're going to have a bad day. Now, don't get me wrong, the C-130 uses turboprops, but the propellers will push anything out of the way before it gets into the intake of the turboprop. So basically, the reason why we still use them is because they were designed to have the trash beaten out of them. And it's a very modular design, so you could just extend the fuselage on the C-130, which is what they're doing right now. What is it? It's an MC-130J or C-130, the J series. They're extended fuselages. So the reason why C-130s are still flying is because you could beat the crap out of them and they don't break. They don't break. You can do a barrel roll with the damn plane, it won't break. And that's pretty damn impressive for a cargo plane, especially a cargo plane with propellers. So yeah, the airframes last a very, very long time because they were designed to be, landed on these very rough and bumpy surfaces, so that puts a lot of stress on the airframe. Coincidentally, the B-52 also has an over-engineered airframe for the same exact reason, because it's designed to carry payloads with dynamic mass. Is that a good way to put that? Dynamic mass, meaning... Okay, so think about this for a second. The B-52 carries like 80,000 pounds of bombs. And if you drop all of those bombs, your airframe, the plane is going from like 180,000 pounds down to 80,000 pounds, like that. Those are rounded numbers. Those are rounded numbers that are made up, but you get the idea. The point is that that puts a lot of stress on the airframe when you're up at the like 50,000 feet where the B-52 kind of rolls. That puts a lot of stress, like, dropping something like that, the wings bend and flex around, so the B-52 is way over-engineered as well. They're super over-engineered for what they need to do because they're designed to carry a lot of bombs and drop them very quickly. So the airframes tend to last a very long time before they stress out. Now, what do you mean? What do you mean airframe stresses out? What does that mean? I don't have any cans on my desk, but if you take you have a can of soda, right? You open it up, right? And then you take the tab and you pull it a bunch of times. Well, that's a load cycle. Planes do the same thing. After a certain amount of time, the aluminum gets weak. And when it gets weak, it snaps off. After a certain amount of flight hours on an airframe, you got to retire it because it wasn't engineered for that. You'll start fatiguing components and then wings pop off. Don't get me wrong, there's pretty good rules about planes especially planes that need to fly people, especially planes that are in the military, about making sure that this doesn't happen. But eventually the airframe's just tired and you got to retire the plane. Eventually. Also turbochargers. Yeah, load cycles, Hokie. That's absolutely a thing. So not exactly the same thing, but the A-10 also belongs in this list too. The A-10 is there because it's A-10s are very low cost. It's a very off-the-shelf thing. They use the same jet engines that you'd find on a passenger plane. It's low cost. It's a very simple design. Also, and it's very good at what it does for the operating costs. A-10 costs nothing to fly. Like comparatively to like an F-35, A-10 costs nothing. It's a very simple plane. Thank you. Bless you. Thank you. Yeah, that's right, right? C5s, they kept upgrading. They retired to C5As and upgraded them to M's and different variants. Yep. Material engineer here. Cyclic stress is a real thing and causes failures. Yep. And you guys got to think about it, dude. I mean, if you want to think about military hardware like we think about spaceflight hardware, if you design something to be reused, right? You know, if you're designing something to be expendable, I should say, it's about making it as light and as quick as you can, like a missile, for instance, right? But if you're designing something to be reusable, especially an airframe, you know, you want, you know, like a C-130, for instance, that plane is going to be landed in combat zones, it's going to get shot at, it flies near the ground, you know, rough, hard landings a lot of the time. Like there's lapse drops where you snag an APC and it goes sliding out the back at like 5 feet off the ground. There's a lot of dynamic things that put a lot of stress on that airframe, but Lockheed knew this and they overbuilt the airframe on purpose. So there's not as much load cycle. Bridges are designed this way, believe it or not. You can design a bridge, you know, there's the moniker like, oh, a good engineer designs a bridge that's just barely stands up. Well, that's not entirely true. Bridges are designed to be able to withstand like 20 times their maximum allotted weight. Why? Because if you have a 10,000 pound truck driving over that bridge and the bridge is designed to hold 12,000 pounds, over time you're going to put that bridge through load cycles and it's going to collapse. If you want to design a bridge that's designed to move a 20,000 pound truck over it, you design it like a 20-to-1 load factor. You design it for like 2 million pounds. That way you know that trucks can drive over that for literally centuries and it'll never break. That's what bridges are engineered. That's why, you know, everybody's like, oh, the infrastructure, we got to upgrade the bridges. Yeah, the bridges aren't going to break as long as they're in good condition. They're fine. Now, the condition of them, that's another story. And, you know, I don't want to get into it, but so the B-52 must have been designed 3 times over. Mumenji, yeah, pretty much. I mean, the B-52 is designed to take, I think it's 80,000 pounds of bombs up to 50,000 feet. That's a lot of cargo. That's a lot. That's a lot of stress on the airframe, especially during takeoff and landing. That's a lot of stress, man. Those things were built to last. They were built to last a long time. That's why we still use them, because the airframes are still good. Why reinvent the wheel? Doesn't make any sense. I mean, the Russians do the same thing with the Tu-95. The Tu-95 was built the same way. This is a long-range strategic bomber. This is strat bombing, guys. You design it way stronger than it needs to be, because you don't want the plane flying around carrying a heavy bomb load at 50,000 feet and hit some turbulence and have your wings snap off. No way. That would be bad. That would be bad for it. Yeah, you don't want that. So yeah, planes like the A-10, C-130, the B-52, there'll always be a place for them because they're so ridiculously well made. They're so ridiculously well engineered, and they don't really cost that much to operate, guys. Like, I mean, the B-52, if I'm remembering right, was a cost plus contract. I'd say we got our money's worth.
Hey, can I talk to you for a minute?
No.
Please?
Yeah, sure, okay. That's a big Twinkie. Tell him about the Twinkie. All right, here. I'm going to load up the Starship footage. I'm going to go see what Brimo's up to. I'll be right back. I'm back. Cookies, Smirks. Or, well, mini muffins.
Discovery, go at throttle.
Condition. It's a 34-monther. All right, let me just pop back through. What did we miss? They're modifying that 11,000. You missed the camper party? Watch it come down? All right, we'll do. How much torque do you want in your truck? Yes. Let's see what we got. Okay. High bay and the wide bay. Okay. Making more staircases. Man, that I'm sorry, I keep eyeing the F350. That thing is a beast. Look at that. How many lugs you want? Yes. That's basically a semi-truck with a pickup chassis on it. She's a beast. All right, let's take a look. Burbs, 35 months, also truck. Blueberry chocolate chips, chocolate chip. That's right, back socket. Okay, so when they lower it, they're going to keep the hooks as low as possible. Yep, there you go. Telescoper over there is getting out of the way. Yep, look at that, retracting the telescope. That's cool, man. Bro, can we just sit here and appreciate how difficult it is to do what that trucker just did in this video? That right there? Oh, frick you. You know how hard that is? That was like perfectly straight. Bringing the boom down. Keep the hooks low. Yep. Yep, he moved the mast all the way forward. Sweet. Oh, cranes building cranes. Cranes helping gamers. Oh yeah, they got the big boy parts coming in. Practice, years of it. I do that all the time in Euro Truck Simulator too. Yeah. Any next-gen fighters that you're a big fan of? I like F-22s, Yoshi. F-22 and F-35B. The F-35A and C are cool, but, dude, Das and I went to a Miramar Air Show. We went to the Miramar Air Show in 2019, late 2019, like right before, or in the before times, right? And, man, dude, I saw an F-35B fly around. I saw it fly around. First of all, it looked like a hummingbird. It was just... And then, like, it flew around, came in, and just went... Boop, boop, boop. Just flipped on the hover thing, and then went down about... Not that quickly. So it was about, like... It was doing its maneuvers. It came in. And it was about that fast. That's nuts. If you think about the aerodynamics involved there... That's unbelievable. It's ridiculous what that plane can do. I really like it just because it's amazing. It's insane. The thing's ridiculous. It's ridiculous for what that plane does. Like, that is a lot. That is a lot of things happening all at once, and all those things happening all at once need to go exactly right to get the thing to go beep, beep, you know? So, yeah, I mean, F-35B is probably my favorite just because it's ridiculous. Harrier's still better. Yeah, laughs in supersonic. Yeah, Vaxock, it's pretty nuts what they can do, man. I think your buys for the F-22 because of me. Well, I mean, Pythos, yeah, maybe a little bit, but also Why do I not want a plane that's literally good at everything? You know, they say, oh, jack of all trades, master at none. The F-22 is good at everything. It is a good bomber. It is a really good fighter. It can attack the ground. It can attack the air. You can dogfight with it. You can kill things from a long way away. You could do reconnaissance with it. The F-22 is literally good at everything. It's good at everything. I don't care what anybody says. It is literally good at everything. I'm teasing. But also, it is good at everything. It's good at everything. Like, it can do anything that an F-15 can. It can do anything that an F-14 can. Well, not except for the carrier landing. The carrier landing part is the only thing that it's not good at. It can super cruise. It's stealth. It can bomb things. It has an internal payload bay. It has the radar signature of a frigging bird. Like, it can do it is good at everything. It is good at everything. And you can attack the ground with it. It has a 20 millimeter cannon on it. Just a measly 10 millimeters smaller than the A-10's cannon. It is literally good at everything. It's also not good at getting mass produced. They made over 100 of them, Synerd, but that's not the F-22's problem. The small African swallow is going Mach 1. Yeah, right. Yeah, exactly, Penta, right? The point is to not get into a dogfight. F-22 versus, an Su-35, Yoshi? Here's the thing about planes. Pilot skill. If you took an F-22 pilot and you put him in an Su-35...
Discovery,
like,
go and throttle up.
It doesn't really matter. It's the pilot skill. If you took an experienced F-22 pilot and put him in like a P-51... and then you took an inexperienced pilot and put that person in the F-22, the P-51 could still win. I'm serious. It's probably because it can go slower. The F-22 can't go that slow. But it really comes down to pilot experience. It's not about hardware. Everyone knows this. It's like saying, who's a better Marine? The Royal Marines because they use the SA-80 or the U.S. Marines because they use an M4? The gun has nothing to do with it. The gun has nothing to do with it. Also, SA-80s are kind of junk, but whatever. SA-58s are better. That's personal opinion. EJ's being an armchair gunsmith again. It really comes down to skill. It comes down to training. And it's very, very, very much true with pilots. I do think that the Su-35 is an amazing fighter. That's my favorite Soviet-derived plane. We'll say Soviet-derived because I'm Russian. We don't say that right now. No, it's my favorite plane to come out of the Eastern Bloc. That and a MiG-29. Those are really good planes. But the Su-35 is... I love that airplane, even now. Tech-wise, the F-22 is superior. Yeah, of course, .com. Yeah, but see, yeah, you're matching generations of fighters against other generations. The Su-35 is last gen. The F-22 is current generation. So that would be like an F-15 going toe-to-toe with an F-4. Of course the F-15 is going to win. But then again, it really comes down to pilot skill. And that's something that Top Gun, everybody's like, you could be my wingman anytime. That's what Top Gun is supposed to teach. Top Gun, that's kind of the reason why Top Gun is a thing in the first place. Because after Vietnam, pilot training went kind of lax because everyone's like, you got missiles and your plane goes faster. You're fine. No. The Navy invented Top Gun, the Top Gun kind of program to better train your pilots. That's the whole point. And that involves newer pilots to Top Gun going toe-to-toe with guys that are in planes from the last fighter generation, and they still lose. It really comes down to pilot skill. I mean, look at Top Gun. Look at Top Gun the movie. Maverick and Goose are in an F-14. Jester is in an A-4. An A-4 is a piece of junk comparatively to an F-14. The F-14 is better in every category. But Jester is a better pilot, so he was able to get him. I know it's a movie, I get it, but this is what Top Gun's supposed to do. It's supposed to teach you that it ain't about how sophisticated of a freaking plane you have. It's about being a good pilot. So that's like target fixation, great situational awareness, good ability to dogfight. Like, that's what being a good pilot is about. It's about knowing where you are. Basically, a pilot with good situational awareness is flying in third-person view. Understand? You got to know where you are. You got to know where the plane is. You got to know what the plane's doing. You got to know how the plane's going to react to certain scenarios. That's what Top Gun is about. It's teaching that. You know, like, so it really doesn't, you know, like, oh, who would win, an F-22 or an Su-35? On paper, an F-22 would win because it has long range rockets. But it comes down to pilot skill. That's the honest truth. It doesn't matter. It really comes down to pilot skill. I mean, look, if you look at the Korean War, that's another good example. There were guys in P-51s that shot in P-47s that shot down MiG-15s. The skill is what matters. The pilot training is really, really what makes the difference. It's not just the equipment. That's only half of it. Just like the gun doesn't make a difference. If there's somebody that's well trained, they're going to know what to do regardless of the weapon. The F-22 is just a tool in a human's hands. It's really, the pilot training is what matters. That's right, Angry Beard. Yep. They thought, oh, the F-4 goes faster than everything and it only has missiles. You're never going to need to dogfight again. Oops. And then guys with F-4s found themselves in a dogfight against a MiG-19, a freaking tractor with wings, and they lost. Funny how that works. An A-1 Skyraider shot down a MiG-15. That's right. When is the Centaur relight? That actually should be very soon. 54 minutes, switch you. Anyway. So yeah, that's who would win, Yoshi? I don't know. It comes down to pilot skill. That's really what matters. And that's something that you really have to learn if you want to be a fighter pilot. It doesn't matter how advanced of a system you have. It's how well you know that system. So like an F-22 in like a Top Gun pilot's hands is pretty much going to be unbeatable. There's no freaking way. But you don't rule out a loss because nothing is unbeatable. Is ULA going to stream it? They're streaming it right now, Swishio. Yeah. Mm-hmm. It is, Ernok. MiG-15 and MiG-19, they're tractors with wings. The Russians designed stuff to be simple because a lot of the people that would be flying those planes are farmers and stuff, man. They design it to be simple. It's not supposed to be, doesn't need to be complicated. It's just good enough. That's right, Fit. Yep. Our tractor with wings is probably an F-16. Yeah, you remember I was talking about planes that are overbuilt because they're designed to land on unprepared surfaces. Every single MiG ever made is designed to land on a dirt field if needed. Yeah, they all are. That's what I mean about a tractor with wings. Yeah, the crane paint job is sweet, Bear, right? Look at this thing. Unbelievable. It's still ridiculous. Even now, it's still nuts. This is still ridiculous, man. I can't believe this thing. I can't believe this thing exists. And, yo, see, check it out. See this segment right here, that segment of metal between here and here? One of these segments right there, with these 3 tabs on it, showed up at the Cape, dudes. We'll probably see it in another video here. The Su-25, exactly, Louisa. The Su-25 is the A-10's Russian counterpart. Only a 20mm cannon, though, so... Guys, I'm going to turn on the fans. It's getting kind of hot in here. If you're over 5'6", you won't fit in a MiG-15, 17, or 19. Yeah, Jim, you've seen me. I can't fit in most planes. I can't fit in most planes, dude. Maybe a C-5 or a C-130 or a C-17, and that's about it. Guys pouring concrete. Yes, I know. A lot of dynamics going on. Cool. We got a bunch of videos to go through from the weekend. So that was the first one. And then let's get to this second one here. So once again, guys, this footage is coming from NASA spaceflight. Mary shot this, Boca Chica gal. Make sure you go and follow NSF. I can't say that enough. They're nice enough to let my stupid butt sit here and commentate on their footage all day. So make sure you go over there and support them, okay? Yeah, pretty much, or not, right? Thanks, Ice King. Hey, Spraz, what's going on? Alright, so those crane parts are moved to the crane, and you see they took part of the... Behind my stupid melon. They took part of the crane apart, and they're adding these bigger segments because they're reconfiguring the crane. A lot of people don't know, and note the ladder for the size of this thing. A lot of people don't know that these cranes are Lego kits. Actually, it would be more akin to a big Meccano set or Lego Technic or something. You can take them apart and put them right back together. You can reconfigure them. You can make the crane taller. You can make it shorter. You do a bunch of things with it. Now, this piece, these two pieces right here, they're conjoined. They're conjoined at the center because this makes up the derrick and the main mast of the crane. What? These are parts of a crane called a Liebherr 11,000. I accept your terms. And the 11,000, see the pieces right there? There it is. Those are the pieces. They're kind of conjoined, but they're kind of not. See? Right there? There's the two pieces. You can reconfigure the crane. You can configure it to be taller to work on a freaking wind turbine, or you could configure it to you configure it to be shorter to pick up heavy parts. I gotta find the technical. Here we go. Watch this. I mean, the thing is a freaking Lego kit, dude. It's really freaking cool. Cranes are kind of a guilty pleasure of mine. Hello, yes, my name is Derek. You rang? You're a crane part. Even the base of the crane, the crawler, it's all designed to be taken apart. It's all modular. The whole thing is designed to be taken apart and put back together, so you don't need to assemble the big crane somewhere else. But see all the different configurations? Now, I don't know which configuration they're using. I think they had this WVB. I think that's the configuration that the crane was in, but it didn't have twin jibs up top. They borrow terms from sailboats, which is funny. But see, you can adjust the amount of segments that you need and make a whole. You can do a bunch of things with them. They're really cool, actually. For scale, goalie, let's see. Oh yeah, there you go. My guy, nice. Yeah. There's some Liebherr 11,000 parts. Oh, they're brand new, dude. Hello. Look at that hook, man. Dude. If you try to kick that thing, you'd probably break your toe. If you tried to move it, you'd probably hurt yourself because, I mean, that's how heavy that damn thing is. It is. That thing ain't moving. Cool. Great pictures. There's the cable. Is that an anchor? Might as well be. Alright, let's jump back over here. Swag, 43-month resub. Thanks, dude. Yep, see? They're reconfiguring the segments here. That hook will be back on the Cape soon. Oh, they're taking the segment off. Look at that. Those are big crane parts, man. Look at the size of that damn segment. It's freaking... Dude. Hold on. Who saw it? Watch the truck. Watch the truck suspension decompress. Watch the truck when they pull the segment off. Yep. Did you see it? Oh my gosh. That thing is heavy. What do the jibs do on the cranes? They give the leverage. It's the jibs are designed for leverage, so you can move the booms and stuff. See that? That's a jib right there. So the thing can articulate over, and you have the leverage to be able to counter the boom. These two telescoping cranes right here are putting together the big parts for the big crane. Cranes helping cranes. They're going to take apart all the segments, and then they're going to add these two pieces right here for the derrick and the main boom. Now, here, let me get this back up and running. See right here? That's the derrick. So on cranes, you have three big pieces coming off of the main pivot. You have the mast right there. There's the mast, the derrick, and the boom. And then up here, this one doesn't have any jibs attached to it, Flykin, but you can attach jibs up here. But you don't need to attach the jibs up there. You can put whatever you want. It really depends. The crane is entirely configurable, which is really cool, man. I think it's so fascinating how smart how well engineered these things are. Like, see this crane right here. This one has a mast. It has the mast, a derrick, and a main boom, but the main boom that's 4 segments up with no jib. This thing is designed to lift something heavy, not very far. That one right there is designed to lift something very big, very far. What's the price? If you have to ask, you probably can't afford it. It's definitely over $1 million. Definitely over $1 million bucks. See all the different configurations? I think that's so cool. And then you can attach a wagon to the back. That's what that thing is called. It's literally wheels that are on a big tow hitch to the back of the crane. If you need to pick something up, you can get big counterweights. And then on top of that, the counterweights are configurable as well. It's really cool. Like I said, they're built like Legos. It's a big adult Lego kit. That's what it is. Self-adjusting wagon, exactly. Yep, they're just a big Lego kit. It's so freaking cool. Look at it, just a big Lego kit. Oh, gotta back that other piece in. They're attaching the derrick parts now. Oh, see the crawler crane is moving. See, there's the mast. See how note that the mast is all the way forward. The crane is literally designed to be assembled, and as they assemble more and more of it, the mast slowly moves backwards. It'll slowly flip back over. Note that the text on it is upside down. It'll slowly pivot back over as you build more and more of the crane. It's really freaking cool, dude. Val's like, I can afford $1 million, hi. Yeah, see? They move the mast back, and they attach the top pins, they move the mast back, and then when the thing becomes straight, they'll attach the lower pins, right? And then they'll take these pendants right here. These are basically steel rods. They'll take the pendants and they'll attach it to the next thing, and then they'll just keep doing the same thing and the same thing. Attach a part, move the pendants, attach a part, move the pendants, move the mast back, and until you have a crane made. It's really freaking cool. Yeah, those things are really neat. And then eventually you have a crane that can lift this. I'm learning. 29 months. Thanks, Pop. That was a tower crane, Ice King, but I know what you mean, yeah. What ship is this? That's 22. Okay, so Lawnart. Got it. 21 wasn't finished. They didn't finish putting all the tiles on. Or, not 21, 22. Excuse me. Damn. Yeah, it looks like there's an access hole right there that's open. Baby Russian like McDonald's. Yeah, Hellfish, of course. I mean, these aren't balloon tanks by definition, but they're I'm not going to sit here and say that they're not using residual pressure to keep the things strong. Ship 24 checkered from what I could see there. Yeah, they're stacking it. And the crazy part about this is, fellas, is that that's one of two. Liebherr 11,000. SpaceX owns the other one, and it's sitting right there. They use it to put Starship on the, or put Super Heavy on the pad, excuse me. Yeah, that big crane. I mean, these cranes are big, dude. Yeah, pretty much Hellfish, yep. Bird. They're building up cinder block berms for the new methane tanks. Oh yeah, Henry, of course. You have to have. I'm pretty sure it's a license, but I'm not 100% sure. Goalie, do you need an operator's license for a crank? For the crane, I would say yes. But I forget. I'll defer to the experts on that one. I don't know. Laying that cinder block. When do we first see those prefab pieces of the tower being put up? Early 2021, Laser Man, if I'm remembering right. But I firmly believe that, you know, this pad took what, like 2 years to make? The other pad's not going to take nearly as long. There's, okay, yeah. Those are the ties, so the crane, that's what the crawler drives on. The tracks for the, what are you doing? He's got it. He's got it. We good. Yo, the guy's surgical with that thing. You see that? Mutter, 78 months. You know, he's surgical with this thing, Jake. Yeah, you might want to ratchet strap that. Oh. Dude, who is this guy? Who is this guy? This guy is surgical with this thing. You see him? He's like, oh, it's a little crooked. Here, let me push it up against the trailer. It's fine. What a legend. You got more methane coming in. Big boy Jenga. Indeed. It really is. We have top men working on it. What kind of top? Top men. You can tell that's methane. You can tell it's methane because the way it is. Ah, we got new locators here. 2 new locators on the booster here. I think these are a datum locator. Basically, they put these in and it lines up super heavy for where it needs to go so it can latch to the other points. I think this is an alignment pin. Couple of zip ties, send it. Well, or just big boy zip ties, ratchet straps. Man, look at that thing. It's chunky. Those slot into the hydraulic power unit covers. Yeah, but Thomas, it doesn't look like anything here is a commodity connection. It just looks like it looks like a trailer hitch, just like what we've seen before. I wonder how much that part costs. This is the stand for Super Heavy, guys. This is what they move Super Heavies around on. Yeah, Spraz, right? I don't know what this thing does, to be honest with you. I don't know what that thing does. Yeah, right. Yeah, right. It's expensive. Have you ever seen those construction vehicle games, like things like an excavator climbing up a tower? Yeah, I know what you mean. Yeah, you can basically walk the excavator up a hill. Yeah, that's cool, man. Speaking of that, anybody watch Whistling Diesel by any chance? He's a YouTuber. Anybody watch that? Did you see the excavator that he bought? He bought a Cat 336 because frick you. Yeah, that's pretty dope. I'm not gonna lie, that's really freaking cool. I'm super jelly. That 336 Caterpillar is awesome. It's so cool. He's a YouTuber, right? That likes messing around with trucks and stuff, right? And Whistler basically does what I'd do if I had money. He bought like a $500,000 Caterpillar excavator. The thing is, dude, it's like freaking rat tank big. It's freaking ridiculous. He just uses it to crush cars and stuff. It's so goddamn funny. It's so stupid, but I love it. It's so awesome. Oh, man. Yeah, it could be Gaw. Yeah, Electron, right? Yeah, just took the excavator. Did you see what it did to that Buick? It just ate through it. Just crunch. No more Buick. Oh, it's awesome, man. That made me happy. Yeah, Fit, I know what you mean. And if I had that YouTube monies, I'd be doing the same thing. I'm not going to lie to you. I'd buy an excavator because I could. Yep, I'd buy construction equipment. Just because frick you. I'm not even kidding. Amazing, a lever excavator climbs to the top. Let me see. Oh, wow. That's really cool. Yeah, Boom, I know. Aren't they cool? This is freaking neat. All right, we got a couple more videos here coming from our NSF buddies here. We just got to make up for over the weekend here. Also, check this out. This was pretty big. This is pretty big news in this video. I think this is the last one. Yeah, Double, that's right. Isn't that the place where you can drive tanks too? Buy heavy equipment and just hire services out. Dude, I would, Fit. I absolutely would. You gotta get a truckload of frick you money, but you can only buy that excavator or a fully kitted out SPMT. Oh, why are you doing this to me? Why are you doing this, man? Oh, don't do that to me. Oh, nice sweater. Thank you. I'll have to show that. Camera, EJ in chat. My grandmother moved about 8 years ago from a farmhouse that was bulldozed and turned into farmland. Oof. Do you think maybe the county office might still have the records of the building plans or something so I could try to rebuild it one day? I'm trying to buy the land and restore it to how it was. Of course. Yeah. If you want to build a structure, you have to register with the county clerk, man. Yeah, of course. They'll have it. Yeah, of course they'll have the plans. Or at least a copy of them. Yeah. Sure. Camrad, I know because this was well before I started streaming, dude. We did that with the house that my grandfather built. My grandfather built his own house, and when he passed away, we had to sell the house because it was 2008 and we were in a recession, right? So we had to get rid of it. So we pulled the deed for it, or not the deed. We pulled the plans. It should be in the county clerk, man. Yeah, you should be able to grab it. You just got to call them. And honestly, Cameron, just tell them what you're doing. Just tell them, like, hey, I want to try to buy this land back. Maybe buy the land back first, but yeah. I was raised out in the 90s in the farmlands of Indiana, so I spent a long time on farmland. Yeah, Cameron, I can't say that I have. I'm a city slicker through and through, dude, but I do understand the appeal of the farm. That, yeah, open spaces, man. Dude, I grew up with, like, 3 houses, like, behind, left, and right, and then a street, and then another house across the street, like, within 20 feet of each other. Like, very, very confined. So, yeah, I understand the big wide open space. That seems like fun. Concrete jungle, that's right, Smirks. Putting the paneling up in the wide bay here. Yeah, double that's for sure. I don't need 10 acres, dude. 10 acres would be nice. But, I don't think I need that much. I just need a place to put the damn cars, dude. Place to build a freaking, basically an Elon tent. That's what I need. That'll be fine. There's the hooks right there. Yeah, pretty much, Buck. It's a lot of work. I went from 2.5 to about 350. Damn, Mutter. Did you buy a homestead or something, dude? Jesus. Oh, okay, Thomas. Give me a link for that, dude, if you could. Yep, he's loading up the counterweights. Stacked together like Legos. Cows. Word. Alright, Thomas. I'll check that link out after this. Yeah, Jabby. That's cool. What's that, Electron? We're come down to Jersey, host a meetup at Digging Land. Oh. Yeah, that's awesome. Yeah, that's cool. Yeah, Ernock, I'd believe it. Of course, Toothless, I retweeted it. Go on my Twitter. Go on twitter.com/EJ_SA. It's the last thing I tweeted on my twit. I hate that I have to use that. Yeah, it's the last thing I posted on there. You're a twit. No, you are. no you. You can't say no you after I say no you. Get out of here. Yeah, Ian, they really do. In you go. That's the unpressurized part, huh? They're above the methane tank from what I can tell. Hey! Right. Yes, yeah, that's a booster dome rig. Grid fin motors are mounted on that. Oh, okay, yeah, I know what that is. How good is my boy Scott McLaughlin? Told you he's legit. Yeah, of course, Smirks. Duh. Yeah, Scotty knows what's good, dude. Oh, there we go. They're moving the pendants around. That's what those big iron, well, steel, like struts are called on a crane. They're called pendants. And then those are counterweights. Biggie! Toyota? Oh. That's strange. No, I'm finishing up these videos. I got a couple more things. We will start the After Space News segment at the top of the hour. Oh, Satana. Oh, Satana. Oh, Satana. Wonder what they're working on out here. Yeah, dirt truck right there. They're adding something. Maybe another Elon tent. Well, Space News yawns.
Discovery, go at throttle up.
Nice, Dama. There you go. Gagan, 72-monther. Thanks, man. There's the cargo bay Pathfinder right there. Yeah, Raven. Still not sure how the heck that thing is going to work, but we'll see in good time. More aero surfaces right there. Thomas, I'd say so. The pointy end, Catholish. Bro. Yeah, it sucks, Dama. It's part of the reason why I want to move to where people aren't near me. Because it ain't any of your business what I'm doing on my friggin' lawn. Damn, those guys are fast. That seems to be a super heavy, the top of super heavy. You see the holes up there, these guys right there for the grid fins. Booster 8 top section. Note the camera up there. See that weird, the weird shaped thing right there? The thing with the hole in it? Camera. That's a camera mount that's looking at the super heavy attachment point. This is where it'll get hooked. That's where it'll hook into the chopsticks right there. See, they got a camera looking right on it. How do they check all those welds? They're X-raying them, Cherokee. Yeah, they're X-raying them. Maybe Sawyer. I mean, Starship, despite never flying, still remains the only launch vehicle to ever be remotely put together, to my knowledge. I think so, Jay, yeah. Man, look at the people standing on that thing, man. Damn. I think it's for the computers, Mutter. Most of the cameras that are on the rocket that we see for the way up aren't for our enjoyment. They're engineering cameras. SpaceX is just better at making them look like it's for us, you know? Yeah, Fugality, you're probably right. It's probably an X-ray and an ultrasound. Stainless steel is tough to weld, dudes. It's tough. Hard to weld it. You really have to make sure when you weld stainless steel that there's no impurities. If there's impurities near it, so like you basically have to make sure that the weld is shielded in gas, right? Tungsten inert gas, that's what TIG stands for. You have to make sure the weld is shielded in gas. The electrical arc is surrounded by inert gas. The reason is, and that's not just like on the front side of the metal, you got to make sure it's back purged as well. It's a really difficult thing to do, because if there's any contaminants or any, like if it's windy, for instance, and it blows the gas away and just atmosphere, nitrogen, oxygen, and other things get in there, it'll contaminate the weld, and the stainless steel will corrode. It'll actually crystallize. Yeah, crystallize. Yeah, it'll make rocks. True story. So it's very difficult to weld that stuff. You got to be very careful. That's so. I mean, and on top of that, it's already rocket science. So it's one of the most stainless steel is one of the most difficult things to weld. And then on top of that, it's going to on a vehicle that's going to fly into space.
Discovery,
so
go and throttle up.
Yeah, they really have to make sure. Welding stainless is fairly easy, honestly. Yeah, Fugality. But if you know any person with a MIG welder can do a good weld, you know, like on steel. TIG is tough, man. It's, I mean, you talk like you do it, you know. I mean, do you? I don't know. I would say that stainless steel is harder to weld than just regular steel. Aluminum's a pain in the butt too because of the heat. You gotta make sure you gotta do it in segments, or else it'll warp, right? No, not good. Just do it 6 days a week. I got you, man. Okay, so for us plebeians, it's difficult. Let me put it to you like that. Nice. Touche. For us plebeians, for the peons, man, it's difficult. That was good, dude. That was good. If you do space vehicle level welding on stainless, there's a place in South Texas that might need you. Yeah, I wonder where that is. Love to learn how to weld. Welding is like drawing, dude. It just takes practice. But there are courses out there, Ravengard. I'd love to weld on space stuff, just do stuff for chemical plants. Yep. I mean, from what I know about welding, this is my limited experience. Fog, you probably know more about this than I do. It's all about the prep work, dude. Like, it's, welding it is half the battle. You got to prep the surface, you got to make sure you got a good ground, etc., etc. Like, once again, my welding knowledge is pretty damn limited, you know? You got to make sure you're back purged if you're doing stainless steel or aluminum or something so you don't contaminate the weld. It's a pain in the butt, dude. For us plebeians, you know? I spend 90% of my time prepping, 10% welding. Yep. Dude, I kind of want to do it. How'd you pick it up, dude? I'd love to go learn how to weld. I mean, I have a stick welder, but it's good for welding like sheet metal, and that's about it. It's not no gas. It's just a Harbor Freight special, man. So it's junk. I mean, it gets the job done, but yeah. I'm gonna go take a course or something, dude. That'd be kind of nice. Rent a welder for a weekend? Yeah. Well, I'll wait till I get a house or something, Sawyer, and then I'll just buy a MIG. I'll just buy a MIG and go from there. I went to JUCO school that just started a weld fab education. From there, I moved to the States and got rather lucky. Fell to the job I'm at. Right on, dude. Yeah, I got you. Yeah, they probably have it, weather guy. I'd have to look around. Well, yeah, like you said, welding's all about wanting to do it, not just doing it. Yeah, damn right, dude. Damn right. Yeah, I'm sure there's something around. I'd do it, man. I'd go do that. You know. Not I'd go do that. I should go do that. Let me put it that way. That'd be fun. Guys, if I figured out how to weld, I could do all the manipulation stuff that I do in Kerbal and in CAD systems. I could do that. I'd just do that in real life. Yeah. That'd be fun. Yeah, they put a wall up in front of those methane tanks. That's masonry work. Look at how nice that cinder block is. That's real good. Real good. Nice and smooth. Is there anything EJ doesn't want to do? No. I saw it, Flykin. Yep. Sometimes Ravengard, yeah. I need to do some welding on the 59, but it's just sheet metal. It shouldn't be too hard. No need to apologize. It's all good. Ram. Oh, concrete pumper. So, guys, this is a pumper. This is a pumper truck right here. So they have two concrete mixers right there, and they're pushing the concrete into the pumper truck. The concrete pumper truck has a reservoir in the back, and then it has a pump. And it pulls concrete from the reservoir and it pumps it up this white pipe right here. That makes it so you can just leave the concrete mixers in one, you can leave the cement mixers just in one spot, right? And then this thing can just lay in a foundation really quick. And then a crew of guys down here, you can see them right there. One guy's controlling the hose, he lays the concrete down, and the other guy smooth it out. And then another guy comes in with a thing that looks like a hovercraft. What's it called? I forget. An aerator? Planer? Backstock? There you go. Yeah. Yep, they're getting ready. So this thing isn't ready to pump yet. They got to extend the boom. I love it, Storm. I love it. Oh, that's so legit. Not as legit as that, though. Check this out. One of SpaceX's oil rigs. Yes, this is an oil rig that SpaceX owns. It's called Deimos. It has a sister oil rig called Phobos. SpaceX bought both of them. This one is moving out of Port of Brownsville to Pascagoula, Mississippi for refit. I don't know what that means. Refit. We know that SpaceX has said in the past that these are going to be used for orbital launch platforms, but yeah, refit. Okay. Phobos and Deimos are the 2 moons of Mars, by the way. That thing is big, man. Look at the doors. That's a big piece of equipment. I don't think it'll do both of those things, Kuro. maybe one of them will stay as an oil rig, and it'll be a propellant depot, and then it'll attach to the other one, which will be the launch pad. Maybe, I don't know. It will go to this dock. Yeah, look at that, dude. Look at the people walking around. Look at that. Only in Texas is that normal. In any other place, that might seem strange. Yeah, look at the people walking around on that thing, man. That thing is gigantic. It's freaking huge. Sure, Kuro. And that's a baby rig. Yeah, right, it is. How do those anchor and spot? Well, Benno, these things would have azimuth thrusters on them, like what's on the drone ships. In fact, drone ships, I'm actually saying that wrong. SpaceX's autonomous spaceport drone ships have oil rig parts on them. That's the right way to say that. Because the oil rig locates itself over the well, and it has the azimuth thrusters that can point in any direction to stay centered over one spot. Drone ship stays centered over one spot so that Falcon 9 can land on the stupid thing. These have azimuth thrusters on them somewhere. Or it could anchor itself, Benno, if it's in shallow water. But yeah, you got to stay over the well. I mean, oil rigs are ridiculous. They're so cool. It's a little mobile. It's got like power plant on board. It's a little mobile factory that just makes oil. It doesn't make oil. It doesn't refine it. It just pumps crude and can drill too. It really depends on how deep the water is that the thing is designed to go to. I don't know if that's a deep water oil rig. I just don't know enough about them to know what kind that is. It's pretty freaking cool though, isn't it? That is a big mother. Look at the tugs. Those are the harbor tugs. They're like, yeah, we're out. Later. See you last, please. Do you think these are part of the bigger plan of launch and landing locations around the world versus just Texas or Florida? Yes. Yeah, absolutely. Mm-hmm. All right. I think we're all caught up on NASA spaceflight videos, and it's 8 o'clock. I got 2 things to show you, guys. One of them was linked by my buddy Stormcrasher. He found brown in real life. Oh, yeah. It's so brown. Oh, it's so brown. You know, Thomas, we'll talk about the neutron stuff tomorrow. Oh, look at how brown it is. Oh, that's amazing. Oh. It's so brown. It looks like a Neva. Vaxhawk, that thing kind of... Broncos and Nevas, yeah, 2 sides of the same coin. It's pretty much what it's supposed to be. Cheap off-road vehicle. Inexpensive, not cheap. Broncos were good, man. They're good. They're good trucks. They rust, though. Very bad. The frame rusts really bad. Nothing else does, but the frame does. But it's also... Look at how brown it is. It's so brown! Brown is the only thing that you can have a couple of different shades of and use it as a trim for another shade of brown. Something like that, Nick. And then here's the last part, a bit of Formula 1 stuff here. Look at the swirl coming off the barge boards. That's cool, man. See that? Look at what these barge boards do with the new aerodynamics. Isn't that neat? Them running through the water, you can see how the aero works. Did you buy another Ford? I freaking wish. I'd take a Gen 1 Bronco, but I'd probably sell it. Fuck. Yeah. Yeah, see that vortex there? That's created there on purpose because they want low pressure. They want low pressure going down in here. Actually, you'd want high pressure on the top of that, but low pressure's coming out from underneath it. No, great picture, Swishio. Very nice. Anyway, so Rudder wants to squad stream. So I will get the squad stream up in a moment here. And we will start Tuesdays Tarkovs with Taradra. Tarky Tuesdays with Taradra. Yeah. I just want to get the burn for the Ghost T mission. We're going to go to coverage for that real quick. And then, yeah, fellas, Del Taradra will be there in probably about 5 minutes.
For anyone that's here,
so I'm going to bring that back up here.
Chance for flooding. Well, thankfully, Ghost can provide us with some high fidelity information to measure that
mission elapsed time T plus 326.
When that flooding can occur, and more importantly, give a sense to the public the magnitude of that particular event.
And can send back pictures every 30 seconds.
Every 30 seconds, which again is tremendously. 10 years ago, we were sending images back every 15 or 30 minutes. 15 was a special request, but every 30 minutes you can get imagery. So again, for back then, that's what we expected. That's what we could do. But technology has leaped so much further forward now. With this capability, it's also added greater capability to our forecasters.
Well, and in severe weather, seconds matter, right? So the
Absolutely.
fact that this is near real-time imaging is really spectacular. All right, we're now at the moment we've been waiting for. Let's bring in NASA commentators Daryl Nail and Mick Woltman to walk us through the mission's last burn and spacecraft separation.
Thank you, Megan. You've been talking about the science, the great science that GOES team
Covered it
will
real
do,
quick,
and
Hellfish, 'cause I'm running out of
meteorological
time.
observations, but we got to get it into its right orbit before it can do any of that. And as you mentioned, we're getting ready for the third and final burn here in just about a minute or so. Mick Woltman joining us, Launch Services Program Engineer. You're looking at live telemetry that is fed into an animation, and there is the Centaur upper stage.
Start on the RL-10.
Attached to GOES T.
Pre-start.
Just heard the call out where they're shooting out the fuel.
Yeah, so we get the fuel in the right projection area.
About
and
45 seconds until MES 3.
So we get the fuel put in there, and they've pre-started the engine to get it ready to go for this MES 3 ignition.
And this will be a 1 minute and roughly 38-second burn.
very important burn here to get GOES-T on its way into proper trajectory. And after we shut down from this burn, Daryl, we'll have about a 3-minute coast before we see separation.
So, fellas, watch. Interesting thing to watch how the booster's pointed here, and I want to try to get this piece in before they fire the engine. So look, Centaur is pointed down. It's because we're at 25-degree inclination. This burn is going to zero out the inclination. So what you should see here is the perigee go up to 32,000 here. So that should go from 203 to 32, and the inclination should go down to 0. There's ignition.
The animation indicating the
watch
RL10C-1.
The perigee is going to circularize at 32,005, and the inclination should go to 0.
890 pounds of thrust.
With control.
So there we hear everything's working good so far, that the propellant utilization system is in a closed loop controlling Centaur.
Performance parameters look good for this burn.
Everything's looking good, as Rob Kesselman is letting us know from the flight telemetry data.
It's 32,000 kilometers straight up
Controlling the
hostile.
mass air to near
No,
zero.
you're not going to see it. It's too far away.
32.
Just about 1 minute remaining in the third
You
burn.
might be able to see it if it was dusk, but it's
We're currently about
midday over
32,000 kilometers
So, yeah,
directly
it's starting to
over
blot it out,
Indonesia.
dude.
And Daryl, there on the left screen, you see the team in the Mission Director Center.
A Falcon 9 upper stage
ULA,
weather guy on
NASA,
Falcon
and our
Heavy,
spacecraft customer for GOES-T watching on for this third burn, as this is the important part of the mission as we get ready to separate.
Note the inclination going down. Perigee
Along the
altitude's going
bottom
up.
row, we've got the NASA and
Vehicle
ULA
body
team.
rates look good at this time.
Yeah, bottom row there is the NASA launch manager Tim Dunn and his
At least I
backup
think
Omar
weather guy. I
Baez,
don't know if they're gonna
along
need,
with
like, a
NASA
special stage
LSP
for it.
Chuck
15
Duvall,
seconds remaining in the burn.
and our program manager Amanda Mickiewicz there. And across the backside next to Tim is launch director Tom Heater, Lou Mangieri, and chief engineer Marty Malinowski from United Launch Alliance.
And we have MECO 3.
Okay.
Reaction control system is now settling at 100%.
Okay, they got the inclination.
That was main engine
interesting.
cutoff number
We have about
3.
160 seconds remaining until spacecraft separation.
The satellite is they didn't put it into a full circularization at 35. That's very interesting. We're eccentric at 9 degrees, which means the satellite is going to do the rest of the work to get to its final deployment. Sometimes they do that. Sometimes they bring the upper stage exactly to where the satellite needs to be, then separate it. And then other times they bring it close. This is close, but it's not exact. You're still 9.4 degrees inclined. The satellite should be able to do this, to finish that up. And if they were going to, if I had to guess, Centaur is going to be pointed probably perfectly up and down during separation. If I had to guess, which seems to be what's going on. You want to eject it. You want to eject it on a coplanar normal vector right here so it can finish out that inclination. It should be able to do that.
Today and putting GOES-T where it needs to be.
For the nerds, they're shooting it that way so it can finish the burn, doing the rest of the orbital burn. Yep, they're jettisoning it on a coplanar. It's coplanar
As you
anti-normal.
can see, Centaur, the thrusters there still moving Centaur around and stabling things out, as Rob Kesselman had mentioned, and getting ready for spacecraft separation.
Just about 60 seconds away from that
Correct,
separation. And there'll be video of this separation.
Vehicle attitude rates are now stabilizing for spacecraft separation. We have just about 60 seconds until spacecraft separation.
Pretty much, Bond.
We won't have the video live, but we will get the downlink about 15 minutes after separation. So look for that on social media, NASA, ULA.
Stand by for separation.
Look on their social media accounts. Again, on the right-hand side is the animation that is connected to real-time telemetry of the spacecraft in relation to where it is around
30
the
seconds till spacecraft sep. Attitude rates in all axes have stabilized at 0.
Some very intense looks.
10 seconds remaining.
The folks on the left.
Yeah, it's important, Daryl.
And we have indication of successful spacecraft separation of the
goes.
GOES-T spacecraft.
Good job, guys.
This is a great moment right there, Daryl, as we see the team celebrating that spacecraft separation. 3 hours we've been waiting for this, and successful deployment of the GOES-T satellite.
Yeah, well, you got some hugs down there.
Lot of good handshakes going on. Man, those are good handshakes. I love those handshakes.
LSP
the victory
manager
handshakes.
Retiring in a few months. And the spacecraft team as well, up across the upper row. Handshakes and congratulations all the way around.
Very good. No,
this is the culmination of years of work that started in earnest.
Probably not, man.
More than 6 years ago. LSP coming in and bringing the spacecraft and launch provider together roughly 2 years ago.
She's a beast.
And now you see this is the completion of that in the mission.
And this is what it's all about. This is what we do every day and live for this. This is a great moment to deliver spacecraft on orbit for our